Hello and welcome to the Learning Lodash video tutorial series by Pact Publishing. My name is Eric Adams and I currently work as a senior full-stack engineer. I've worked in web development for over 10 years in industries such as insurance, publishing, telecommunications, and more. I've been involved primarily with front-end technologies for the last 6 years, and I love the enthusiasm in the JavaScript community. Lodash has always made quality, performance, and simplicity keys to its development. Because of those traits, I've made it my go-to utility to speed up application development. In this first video, we are going to take a look at what will be covered throughout the Learning Lodash video tutorial series. During the series, we will use Lodash and the materials covered to build out an API and client-side application for creating and cataloging recipes. In the end, we will have built the basics of a reusable component-based framework using Lodash. In the first section, we are going to introduce Lodash and our recipe application. We will check out both the client and API code, and we will install Lodash in each repo. We will also configure our application to include Lodash using CommonJS modules and test out our client-side build process. In the second section, we will look at how we can build out a recipe listing page using the Lodash Collections API. We'll work on defining a recipe list response in the API, and then build out the template to display that list on the front end. We'll also display tags used to catalog each recipe, along with the most popular tags in the application. Finally, we'll build an input filter on the front end to help locate a recipe within a list. In the third section, we will build a form to create and tag new recipes in the application. We'll use Lodash array functions to search for existing tags and to determine what new tags will be added to the system. As we build out the front-end application, we will want to create reusable components. To accomplish this, in Section 4 we'll create a base controller that will handle loading templates compiled using Lodash. We'll also learn how to extend that controller with Lodash and add our own view properties to extend controllers. In Section 5 we'll take a look at formatting the display of recipes using the Lodash string functions. We'll also take a deeper look at writing templates that will be rendered using Lodash. Lodash contains a set of miscellaneous utilities, and in Section 6 we'll leverage them to finalize our recipe details. We'll list out the recipe ingredients with quantities of each one for display. We will also add login to our application. In the 7th and final section of the course, we'll look at the requirements for deploying our application. We'll review the various build options available through Lodash CLI, and we'll add minification to create an optimized build of Lodash for our client-side application. By the end of this course, you should have a firm understanding of how Lodash helps to enhance development on both the client and the server. You also will have developed an application powered by reusable components built using Lodash. I hope you're excited to join me in this course as we dive into the features and the power of Lodash. Hi, and welcome to the first section in Learning Lodash, aptly titled Hello Lodash. In this section, we will introduce Lodash, the JavaScript developer's utility library of choice. We'll talk about how Lodash simplifies JavaScript development and why we're using it to build our application. We'll also set up our sample application and set up Lodash to be installed as a dependency of our application. Finally, we'll set up some small scripts that will build our application code in a way that we can use Lodash modules on both the client and the server. Now we move on to the first video of this section that will introduce us to Lodash. Lodash has become an essential library to leverage in creating efficient JavaScript applications. This video will give us some background on the Lodash library and how it will work within our application. In this video, we are going to take a high-level look at Lodash. We want to understand not just why Lodash exists, but why it has become an essential tool in the developer's toolkit for building JavaScript applications. We'll see the reasons why Lodash has become one of the most depended upon libraries in the JavaScript community. We'll also take a look at some of the issues that Lodash was created to simplify and why it is an excellent choice for our application. Lodash was originally created as a fork of the popular underscore utility library and was meant to exist as a drop-in replacement for underscore. Underscore exists as a hard dependency of Backbone and provides a number of convenient methods for Backbone models and collections. As a drop-in replacement for underscore, Lodash was able to work seamlessly with Backbone-driven applications. The question then became, why should developers make the switch? The guiding principles behind Lodash make a convincing argument for developers. Performance is a key attribute in the development of Lodash. Methods are optimized for particular browsers to ensure that you consistently get the optimal performance from the browser in which you are running Lodash. Quality is also key. Lodash strives to maintain 100% test coverage on its codebase and runs tests against multiple browser environments. Lodash also offers additional methods that are needed by developers and additional build options that can provide a more efficient code footprint for newer browsers. Today, Lodash has effectively become a superset of its original counterpart. It offers utility functions for JavaScript array and object iteration, string manipulation, math and date handling, a customizable template system, and much more. It is one of the most depended upon packages in the Node.JS ecosystem, and contains all the necessary tools to create a fully functional JavaScript application. Lodash was built to work with the browser's APIs and contains both modern builds and compatibility builds. This gives us access to iterators such as forEach and filter, along with other object methods that are not natively available in all supported browsers. Lodash also provides a command line tool for creating custom builds that contain just the APIs or methods you need to build your application. We'll discuss the command line build tool in a later section of this video course. Lodash also works well in the V8 runtime provided by Node, making it an excellent choice for scripting apps that contain both client and server components. Our application will provide an API as well as a client-side user interface, making Lodash a good choice to leverage within our codebase. Lodash will be used on the server side to help aggregate, filter, and search data to display on the client. It will be used on the client side as the basis for a modular component-driven framework that uses controllers to retrieve data and templates to display that data to the user. When we're through with this course, I am confident you will see the value of Lodash in speeding up our development and in simplifying the code required to run our application. In this video, we have learned about Lodash, the foundation of our application and the basis for our video course. We reviewed the history of the library, how it began, and why it became the utility library of choice for developers. We discussed some of the features of Lodash, as well as its efficiency on the client and the server. Finally, we discovered some ways in which our application will use Lodash to accomplish its objectives. In the next video, we will introduce our sample recipes application. We'll go over the requirements for developing our application and install the application repositories. Hi, and welcome to the next video in our course, Learning Lodash. In the previous video, we introduced Lodash, the library that is the basis for this course and the foundation of our application. We reviewed some of the features within Lodash, as well as its history and rise in popularity among JavaScript developers. In this video, we are going to take a look at installing the sample application for our course. We'll start by taking a quick look at the things you will need to install before working on the application. Then we'll look at the application repositories. Finally, we'll create a local copy of the repositories and get set up with the branch that we'll use in the next section. To follow along with the code samples in the course, you will want to get a local copy of the application. To do this, you will need to install Git, since the application is managed by source control in 2 Git repositories. Several operating systems have Git installed by default, and you may already have it on your system. However, if you do not, you can get it from the Git homepage or by installing the GitHub desktop client. Alternatively, you can install Git through your operating system's package manager, such as Yum or apt-get for Linux, Brew for OS X, or Chocolatey if you have Windows. The second requirement is Node.JS, which will be used to run both the REST service and the web client for the application. You can install Node.js through the Node homepage or through your operating system's package manager. As I mentioned before, the application is split between 2 repositories. There is a repo for the API that the application will use to save recipes and tags. This API will be served using Express, a Node.js application framework that is well suited for building RESTful routes. Lodash will be an essential part of manipulating the data used in the API's responses. There is also a repo for the client application where the user will be able to create, browse, tag, and share recipes. This client will be built using components that leverage various APIs within Lodash. These components will be built as separate modules and will use Node.js on the client side to convert those modules into a single JavaScript file using Browserify. We'll serve the client-side application using Node Static, a Node module that works as a static file server. Both the Recipes API and Recipes client repos are hosted on GitHub, so if you'd like to, then please take a moment to browse around the contents of each repo. To get copies of both repos, first create a directory that you would like to clone them into. Then from the command line, cd into the directory you've created. You will run two git clone commands, one for the recipes API repo and one for the recipes client. Once you've successfully cloned both repos, you can open each directory created and see the basic file structure within each one. Note that both the recipes client and recipes API repos contain a package.json file. We will be looking more at that in the next video, as that is where we've defined what libraries we want to use in our application, including Lodash. Now that we have local copies of each repo, let's check out the branch for the next video. Each video with code modifications will have an associated branch. The branch for the next video is called video-1-4. To get that branch, run git checkout video-1-4 in both the recipes API and recipes client repos. This will get you set up for the next video in the course. In this video, we have installed the necessary requirements for running the sample application. We created local copies of both the client and API repos, and we learned how to switch branches to follow the different sections within the course. In the next video, we are going to take a look at how Lodash is installed on both the client and server applications and how we get access to its APIs from within our application. In the previous video, we reviewed the requirements for installing the sample application. We have set up local copies of the repos we'll use throughout the course and demonstrated the process of switching branches for each section of the course. In this video, we are going to take a look at the available methods to install Lodash in a web application. We'll talk about why npm is a good choice for installing Lodash in our application, and we'll create the necessary configuration files to install Lodash via npm. Finally, we'll take a look at the directory structure created by npm and learn where Lodash is installed within that structure. Since Lodash is used as a utility library, it is often found as a dependency in other libraries used in both Node and the browser. To meet the needs of its dependent libraries, Lodash is available for installation through JavaScript package managers such as npm, Bower, Component, and more. It is also available on several CDNs to reference directly through a script tag in your application. Since our sample application has an API built on Node.JS and a client application for the browser, npm is a good option for our installation. Using npm, we can include Lodash modules in our application using a consistent method. We can also create builds for our client application using Browserify that will generate a single file ready for deployment. To get started using npm, we will need to set up a configuration file for both of our repos that will indicate what dependencies we want to include in our application. This file is called package.json and will reside at the root of each repo. Let's first create this file in the recipes client repo. To create this file, we will run the npm init command. When you run npm init, you will be presented with a series of prompts that are meant to provide basic information about the package you're creating. For our purposes, most of the configuration properties can use their default values. Simply press the Enter key to continue through the prompts. There is a value we'll want to change called the entry point. This is the main file loaded by the application. For that, enter assets/js/app.js, which is where our compiled JavaScript file will be located. When the remaining prompts have been completed, a preview of the package.json file will be generated along with the message, "Is this okay?" Simply press Enter again to accept and create the file. Now that the package.json file is created, let's add Lodash. npm also provides a command to install dependencies aptly named npm install. To install Lodash, type npm install -S Lodash. The -S option instructs npm to add the installed dependency to the package.json file so that future installations of the application will automatically include Lodash when npm install is run. Once the installation of Lodash is complete, you might notice a Node Modules folder has also been created in the repo. This folder contains all dependencies installed for our project through npm. To see where Lodash is located, type cd node_modules/Lodash. In that directory, type ls-l or dir if running Windows. You will see a listing of all the modules that Lodash provides for an application. There is also a file called index.js that contains all Lodash modules in a single location. Now that we've installed Lodash into the Recipes client repo, we'll install it in the same way into Recipes API. In that repo, you'll find a package.json file has already been created. This is done using a tool in the Express framework to set up an Express application with its required dependencies. We are also using Node.JS DB as a way to maintain a basic data schema to drive our API. To add Lodash to these dependencies, run npm install -S Lodash. This will update the package.json file and install Lodash in the Node modules directory of the repo. In this video, we have learned about the various ways Lodash can be included in applications written for both the server and the browser. We used npm to create a package.json file for our Recipes client repo and installed Lodash to both the Recipes client and Recipes API repos using npm. In the next video, we are going to include Lodash modules in our application. We'll also take a look at how our Recipes client modules are built with dependencies into a single file for deployment. Hello, and welcome to the final video of this section of Learning Lodash, which is about adding Lodash to the application. In the previous video, we looked at how Lodash is included into our project with the Node Package Manager, npm. We set up a package.json file that will be used to install Lodash into our application when we deploy, and reviewed the installation location for our dependencies. In this video, we are going to take a look at how Lodash modules are imported into the application. We'll use a common method in both the Recipes API and Recipes client repos, but we'll need to create a single JavaScript file for deploying the Recipes client portion of our application. To accomplish this, we'll create a build task for our client-side application using npm and Browserify. Finally, we are going to test out our build that includes a sample Lodash module. To import Lodash modules in our API, we're going to use Node's require method. Using require, we can choose to import the entire Lodash library or simply the portions we need for our controllers. In the browser, we can use require as well, but we'll need to take an additional step. This is because all browsers do not natively support JavaScript modules. There are, however, some excellent libraries that provide support for modules. To use require for importing modules in the browser, we'll use Browserify. Browserify will allow you to write common JS modules in the style that Node and Lodash support, and will generate a JavaScript file that all browsers will support. It is installed as a command line tool using npm, and works well on its own or with other build and deployment tools. There is also a watch mode available for Browserify that will monitor any changes in your application and automatically generate a JavaScript file to test in development. To run Browserify, we'll also use npm, since npm can manage command line tasks through the npm run command. To install Browserify for use in our project, run npm install -g Browserify. This instructs npm to install the module to a globally available location for all dependents. This is particularly useful if your Node module has a command line interface. To get the Browserify tool to monitor for changes to your files during development, run npm install -g watchify. Once we've installed both tools, we'll edit our package.json file to use them as npm run tasks. We'll want to create two tasks in the script's configuration of package.json. The first we're going to call build. This will be the production build script that runs Browserify. We can add upon this script later for additional optimizations such as minification. The other is called dev. This task will monitor for changes in our application files and respond to those changes by running Browserify. The dev task also runs Browserify in debug mode, so you can use source maps in your browser's dev tools to help debug your code. Once you have saved your package.json file, let's edit our app/main.js file and include a Lodash module. We're going to include one of the more commonly used collection functions, each. We'll dive more into collections in the next section, but what we're doing right here is simple. We'll first use require to include the Lodash each function, which is used to iterate over an array or object and execute a supplied function to each value. Then we pass a list of names to each, along with a callback that simply logs a greeting to the console. Once you've made this edit, from the command line, type npm run build to generate the JavaScript that will include our application code. Once npm run build completes, let's open up the assets/js/app.js file to view the output. Notice now that we have our application code, including the Lodash module we've required. All of the dependencies are managed by Browserify, so we can keep our custom application code separate from Lodash or any other modules we might include during development. Now that we have set up our recipes client build system, we are ready to dig into writing our application. In this section, we were introduced to Lodash and learned about its role as a cross-functional JavaScript utility library. We were also introduced to our recipes application. We discovered how to install Lodash and other dependencies into our application using npm. Finally, we created a system for building our client-side application with reusable modules through Browserify. Now that we have the code and the tools that we need, we're ready to dive into development. Excellent work! In the next section, we are going to start leveraging Lodash collections to build our recipe listing API and landing page for our application. We'll use several methods within Lodash collections to enable client-side filtering and search for recipes by name. This will also introduce us to the first components that we will build for the application, including the recipes card that we'll expand upon in later videos. Hi, and welcome to the second section in learning Lodash, which is working with a list of recipes. In the previous section, we introduced Lodash along with our sample application. We installed the necessary dependencies to develop our application and installed Lodash. In this section, we will begin working with the Lodash Collections API to display a list of recipes. After building the list of recipes, we will build an input that filters the list by a username. Then we will write a transformation that will display the total number of recipes for each tag. Finally, we'll create a search box that will run a basic text search for recipes. Now we move on to the first video of this section, where we will build a list of recipes to display as a landing page for the user. In this video, you will be introduced to the Lodash Collections API through one of its more common iterators. You'll also get a first look at how components will be structured within our client-side application. In this video, we are going to start by looking at our API endpoint for returning a list of recipes. We'll build upon our API using the Lodash Collections API and its forEach method. Then we will take a look at the recipe card component that we will use to display recipe data on the front end. The recipe card is just one type of component that we will create for our application, and all our components will share some common methods. We'll review those common component methods and create a new recipe list component that will generate recipe cards for each recipe in our list. To get a list of recipes for display, we first need to create an API endpoint for retrieving the list. Our recipes API already has this endpoint set up for us. What we're going to do is enhance this endpoint with the ability to expand relationships that are defined in the recipes data structure. First, we'll cd into the recipes API repo. Then we'll run git checkout video-2-1 to get the code we need to follow along with the video. After you have checked out the code branch for the video, run npm install to fetch the required node modules for the API. In your code editor, open up routes/recipes/index.js. This file contains the route required to get a list of recipes. Next, from the root of your recipes API repo, run npm run start to start the Express API server. In your browser, go to http://127.0.0.1:3000/recipes. In my browser, I am using a Chrome extension called JSON View to view the API responses in a readable format. I recommend installing either JSON View or another JSON formatter if you have trouble viewing the responses in your browser. On your screen, you will find a list of recipes, each with some information about the recipe, including the ID of the user that created the recipe. This ID won't be as useful to the client as the actual user information, so we'll edit routes/recipes/index.js to display the user info. Lodash provides a collections API with methods to iterate over and manipulate a JavaScript array or object. We'll use the forEach method in Lodash to execute a function on each recipe that is returned from our data store and load the associated user data for each recipe. To do that, first include Lodash in the route using require. We're going to look for a query string parameter on this endpoint called _expand, which indicates a field in each recipe that is linked to additional data in our data store. If we have a value for _expand, we're going to load the associated list from the data store. Then we'll iterate over each recipe using for each, find the data record for the ID supplied, and create a recipe property with that expanded record. Now that we've added the expand parameter, from the command line, press Ctrl+C to kill our Express server, and then run npm run start to restart the server. In the browser, load http://127.0.0.1:recipes?expand=user. Notice how we have a user property in our data that includes a username. Now let's turn our attention to the recipes client repo. First, cd into the recipes client repo and run git checkout video-2-1 to get the code required to complete this video. Once you are checked out to the video-2-1 branch, open package.json in your code editor. We have added a couple more dependencies here that would be good to understand. The whatwg fetch dependency is a polyfill for the window.fetch API that is provided in certain browsers. We'll use window.fetch to make AJAX calls to our recipes API. The next is ES6 promise. We install this as a polyfill for the new JavaScript promises API that is used by window.fetch. The final dependency is required for development only. It is a Browserify transform called stringify that provides the ability to import templates using require. This transform is now also added to the npm run dev and npm run build commands. From the command line, run npm install to get these dependencies. Once npm install is complete, let's open our base component file at app/components/base/index.js. This basic component system will be expanded upon later in our video course, but right now it contains properties shared by most components. That includes an HTML element that is the root of the component, similar to how other JavaScript frameworks encapsulate the DOM. There is also a template that can be compiled by Lodash that is used to render data from our API to the DOM. We'll dig more into templates in a later video section. We also have methods to append and remove elements within a component, and a render method that is used to render the component into the DOM. Now let's look at our recipe card component at app/components/recipes/card/index.js. This component has no functionality yet, but contains a basic template it will render at app/components/recipes/card/template.html. This template simply requires a data object that contains title, description, and user properties to render. This is the component instance that we will create from within our recipe list. To create our recipe list component, let's create a new directory at app/components/recipes/list. Within this directory, create a file called index.js. This will be our component definition. In this file, we want to first require the base component we want to extend and the recipe card component we'll use to populate the list. We also want to require two Lodash methods, create and for each. The create method is used to create a new object prototype from a given blueprint, in this case our base component. We'll cover this more in section 4, but right now it's important to understand that this gives us access to the properties and methods we saw previously when reviewing the base component. As in our API, for each will be used to iterate the list of recipes that we get back from the API. In this component, we first want to create a constructor for the recipe list that will call the base component constructor. Then we will use create to inherit from the base component prototype and add in our new constructor. Finally, we will override the base component render method to call window.fetch on the API endpoint created earlier. The return of window.fetch is a response object which we must first convert into a JavaScript object using response.json. Using the promise returned from window.fetch and response.json, we iterate the JavaScript object using forEach. In the callback passed to forEach, we create a new recipe card instance for each recipe. We are creating the element to render the card within this iterator since it does not already exist in our index file. We then call render on the card, passing in our recipe data, and append the card's element to our list. Once the recipe list component is created, add the component to module.exports and then save the file. From the command line in the recipes client repo, run npm run build to build the compiled JavaScript assets for the components that we just built. Then run npm run start to start the static file server to serve up our application. Load the application in your browser at http://127.0.0.1:9000. You will see that each recipe retrieved from the API is now displayed in a card format that we can add upon in later videos. This video covered a lot of new concepts within our codebase, and now we have laid the groundwork to write even more components for our recipes application. We created an API endpoint that returns a list of recipes and optionally adds the user that created each recipe using Lodash's forEach method. We reviewed the base component and recipe card component that we'll use throughout the tutorials, and we created a recipe list component that uses Lodash's forEach method to create recipe cards for display. Great work! These are your first steps to mastering Lodash. In the next video, we will continue to work on our recipe list, adding an input that will filter by the user that created a recipe. In the previous video, we learned how to add user information to our recipe list API endpoint. We also learned a bit about the component system we'll use to interface with our API from the client side, and we built a component that displays a list of recipes. We accomplished these tasks using the Lodash Collections API and the forEach method. In this video, we are going to take a look at building a text input to filter our recipe list by username. We'll first make the necessary modifications to our CSS and index.html file so that we can later add the filter component to our page. Then we'll build out the filter input component utilizing the reduce method in Lodash Collections to extract text from each recipe card. Finally, we'll modify the recipe card component to make it a filterable component using HTML data attributes. The first thing that we need to do is check out our recipes client repo to branch video-2-2. To do this, open a command line window, go to your recipes client repo, and run git checkout video-2-2. This will get you the code you need to follow along with the video. After you've checked out the branch, run the command npm run dev. This will track the changes made to our JavaScript components to recompile our JavaScript application. The first thing we need to do before adding our filter component is to make room for it on the page. To do this, we first need to style a couple of selectors in our CSS at assets/css/main.css. The element we'll use to contain our input will have a class called recipe-filter, so our selectors will reference that class. We're going to add the filter input at the top of the page next to our page title. Our page title element has a bottom margin of 16 pixels, so we are going to position our filter in the page header with a relative offset of -16 pixels on the bottom. We also want to remove any margins that might be part of the component since we want it to render relative to the page title without introducing any additional space. Once we have the CSS in place to add the filter, we need to add some markup to our index.html page to contain the component. To do this, let's first replace the div with class page-heading with a row element using the same class. We should add an end attribute so that our CSS knows not to add any additional margins or padding to the row. Within this row element, we will add 2 column elements. The title will take up 8 columns, and the input filter will take up 4. We'll add our page title to the 8 column element, and then add a container for our recipe filter to the 4 column element. Remember that we need to use the recipe-filter class to utilize the styles that we previously added. The row and column elements added here are specific to the underlying CSS framework called Cube. If you would like to learn more about the grid and styles seen here, take a look at https://imperavi.com/cube. Now that we've made some room for our filter input, let's build the component. Create a new directory structure at app/components/filters/input and create a file in that directory called index.js. Next, open up the file in your code editor. As we did before in the recipe list component, we are going to require our base component and Lodash's create method to inherit from our base. We'll also require the for-each method again, and this time we'll also require the reduce method. Using the reduce iterator, we can convert a collection to a single value, which is how we will obtain our usernames to check against the input filtering. After adding our require statements, we will add our constructor for the filter input, which we'll call our base component constructor. Then we'll add a call to create to inherit our base component prototype. We can copy over the getTemplate and render methods from our recipe card component, since they will be implemented the same way here. Now we need to add our methods to filter the user's input. Our base component constructor calls an init method that we can use to assign any configuration properties passed to the constructor or to set up any event handlers for our component. In this case, we will assign a property called filter that represents a parent selector for a filterable list of DOM elements. We'll also set up an event listener for the input event that is fired when the value of an input field changes. The handler for this event is called filter items. The filter items method will retrieve a node list of elements that have a data filter item attribute set on them and are descendants of the filter selector we defined in our init method. We also need to get our input element from the event object using event.target and get the text value of that input. We then iterate over each element in the node list using Lodash's for-each method, calling a filter item method and passing the input field's text value. The filter item method will get all elements in our item with an attribute of data filter text. In our case, this would be any element in our recipe card that we want to use in our filter. We then use the reduce method from Lodash on each element to use in the filter to build a text string. The iteratee for our reduce method accesses the element's text content or inner text field and adds it to the current value of the reduce. The third parameter in our call to reduce represents the initial value of the reduce. In this case, it's an empty string that we can build upon. We create a new regex object with our filter input field's text value and then check if it matches against our reduced element's text. If the text value matches, we unset the item.style.display property. If it does not match, we set the property to none to hide the item. This means that only the recipes that match our filtered text will display. Our template for the filter input will exist in the same directory as the JavaScript. Let's create a template.html file within app/components/filters/input and open this file for editing. The input will be wrapped in a form element with some additional classes for styling. In the form, we add a nested row element using the end attribute and a nested column element spanning 12 columns. The input element will be of type text and will have a placeholder that is defined when we render the input component. For now, we'll use the Lodash template delimiter with a placeholder property. Once we save these files, we can then move on to rendering the input in our main.js file. Open up the main.js application file located in the app directory. Below the call to list.render, let's add a require for components/filters/input, passing a relative path to that component's index.js file. We'll call the module recipe filter since we're using it to filter our recipe list. Create a new recipe filter instance and configure our element selector to the recipe filter class that we added earlier to our index file. Our filter selector should be set to the recipe list class. On the next line, add a call to filter.render, passing in a data object with an appropriate placeholder for the input template. This will add the filter to our page, but we still need to make our recipe cards filterable DOM elements. To do this, open up our recipe card template at app/components/recipes/card/template.html. We'll first add a data filter item attribute to our recipe card element. This indicates that each card will be iterated in our component's filter items method. Second, we'll add a span around our template delimiters for user.username and add a data filter text attribute to the span. This indicates that the contents of the span tag are going to be a part of the filter text matched against our input. Once the card template is saved, reload the browser and type one of the usernames into the filter input. Notice that only the cards matching the entered username now display. We've now added filtering into our recipe list. In this video, we built out a new component for our front end to filter our recipe list by a username. We made the necessary modifications to our style sheet and index file, and we added attributes to our recipe card to enable filtering on the recipe list. We've made a lot of progress on our application's landing page. In the process, we used another method in the Lodash Collections API, reduce, which was able to simplify the text extraction from our recipes for filtering. In the next video, we are going to introduce recipe tags. We'll build out the functionality required to fetch a list of tags to display on the front end, along with total tag counts required to promote popular tags. Hi, and welcome to the next video where we will discuss displaying recipe tag totals. In the previous video, we created an input that filters recipes by username and utilized Lodash's reduce method to complete that task. We also went over the steps required to add a new component into our application, including making CSS modifications and adding our component into the application's main.js file. In this video, we're going to build a new API endpoint that will display tags used within our application. We'll use a couple more methods from the Lodash Collections API to gather the total number of times a tag has been used in a recipe, and then add those totals to our tag list response. We'll review the changes required to add a component for displaying tags on the front end, and then we'll build out the component for displaying tags with totals. The first thing we'll want to do is check out our recipes API repo to branch video-2-3. To do this, open a command line window, go to your recipes API repo, and run git checkout video-2-3. This will get you the code you need to follow along with the video. You'll find a couple of files updated, including app.js, which loads a new set of API routes in routes/tags/index.js. Open up index.js in your code editor, and you'll find that the route has been created for listing tags. What we're going to add to this section is the ability to include the total number of times each tag has been referenced from within our recipe list. To do this, add a call to require Lodash below the other dependencies used in this route. Then, let's load the recipe tags relational structure from our data store. This is a mapping of recipe ID to tag ID that we'll use to build our totals, and Lodash makes this extremely simple using the countBy method. The countBy method will take an array or object and pass each of its values through a function, where the function returns a value that is aggregated. Using countBy, we are able to iterate our mapping table, and by returning our tag ID from the function, we get a resulting object that has the tag IDs as its keys and the tag counts as its values. We use two additional Lodash methods to get the value of each entry in the mapping table as well. After we've built our totals, let's load the tags. We'll use another Lodash method, map, to add totals to the tags. This method iterates an array or object and returns a modified array. In our case, we will add a property to each tag in the tagged list called total and set the value of total to the matching value in our totals object. In calling both countBy and map, notice that we've used Lodash's chaining feature, which for these iterators is resolved by calling value. In Lodash, chaining methods together will optimize the number of iterations required to complete a chain using a technique called lazy evaluation. You'll see chaining used in many of our examples with Lodash. Once you have saved the file, run npm run start from the command line and load in a browser http://127.0.0.1:3000/tags. Notice that we have a list of tags with a tag count. Now we'll move on to adding the component into our application. In the recipes client repo, first check out the branch section 2.3. You'll find that a few files have been updated, including index.html and main.js, and that the tag totals component and template have been added to the repo. The index.html file was updated to add some room for the tag totals component, and the creation of the tag totals component was added to main.js. This is exactly how we added components in the previous videos. The process of inheriting base component and calling create and render are the same as previous videos as well. So from this point, I'll help set those up so we can get right into building the important functionality of our components. Now let's open up app/components/tags/totals/index in our code editor. Below the require for the create method, add in a line to require the for each method. This method will be used to build out a tag list similar to the recipe list. In the render block, add a line to create a new document fragment. This will hold our list items while we iterate tags. Next, let's add a call to window.fetch, passing in the API endpoint that we just created. In the promises resolution, we'll convert the response object to a JSON object, and then in the resolution of the JSON conversion, we'll iterate our list of tags. Add a call to for each, passing the tags as the first parameter and a function as the second. The function will create a new list item for each tag and set the HTML of that item to the tag title. We'll also add a badge display for the tag totals and append the list item to our document fragment. After we exit the for each iterator, we grab the unordered list from our template and append the document fragment, rendering our tags to the page. Notice how the second promise callback is bound to this, which is our object instance. We want to access this.el from within our callback, which is why we bind the function in the component's context. You will see other references to bind in various methods written during the videos. Once you've saved the index.js file, run npm run start from the command line and load the app in your browser. You'll now see a list of tags included in the display. We now have a list of tags that we can build upon for further recipe list filtering and sorting. In this video, we created a new API endpoint for retrieving a list of tags along with the total number of times a tag has been referenced. We introduced two new Lodash collection methods when building out our API functionality, countBy and map. Finally, we built out the fetch and render of our tags within our tag totals component. In the next video, we'll continue working with our recipe list by adding search capabilities to our API so we can find a specific recipe or set of recipes within our collection. Hi, and welcome to the next video in Learning Lodash Section 2, Finding a Recipe in the Collection. In the previous video, we used the Lodash Collections API to get a list of tags with tag totals for display in our recipe application. We learned how to use the countBy method to easily accumulate occurrences of a value and how to use the map method to update values in the tag list that were then returned in the API response. In this video, we're going to add a basic search filter to the API so we can limit the recipes returned in our list to those that match a description. We'll add this functionality into our existing recipe list API endpoint, refactoring the existing code to work with our new filter. We will also use the Lodash filter method to limit the results returned by our search query and then view our API responses both with and without filtering. To begin working on this tutorial, first go into your recipes API repo and check out the branch video-2-4. We're going to refactor the existing recipe route in routes/recipes/index.js to chain together a call to Lodash's filter and map methods. Lodash will optimize these methods where it can to reduce the number of iterations required to obtain results. To begin refactoring the existing code, first let's initialize the relation variable outside our condition. Our try-catch block will simply set relation if it is able to successfully retrieve the requested expand value from the data store. Next, let's cut out the for each block since we want this now to execute inside a map call. We'll remove for each, simplifying our try-catch block. Our catch block will also log error.message for cleaner logs. Now it's time to add our search filter. To do this, assign rec.query.queue to a variable called queue. This will be the search query parameter. After that, we'll create a new regex object only if the queue variable is defined, so we don't unnecessarily filter our recipes. We'll also set our regular expression to be case insensitive using the I flag. Now, inside our call to res.json, wrap the recipes variable with the Lodash global and chain a call to filter. The filter callback should return a truthy value if the element in the collection should be kept, and a falsy value if it should be discarded. This is an improvement over the for each that was used previously, as we no longer need to iterate elements that don't match our search filter. If our QReg variable is set, we should match recipe.description against the search query and return the result. A successful match will return an array which is a truthy value, and a failure to match will return null, which is a falsy value. Next, chain a call to map, which will iterate over the filtered recipe list. In the map method callback, we will check for the existence of the relation variable that was established earlier. In the if block, paste back in the code that we cut earlier from the for each block. This will handle setting the expanded relations in our response. Below the if block, return the recipe so that the map iterator can properly build an updated array of recipes. After the call to map, call value to resolve the chain. This will provide us with an optionally filtered, optionally expanded list of recipes. Once you've saved the index.js file, run npm run start from the command line. Then load http://127.0.0.1:3000/recipes?expand=user. Notice we have our recipes listed as before. Now add a queue parameter to the query string and enter some encoded text, such as a healthy snack. Press enter to reload the response and see now how the recipes are limited to those that match the description entered. We have now added a search filter to our API. In section 4, we'll discuss the client-side component system some more and build out a new search filter component that will reuse some of the functionality from the filter input built in video 2.2. It will also call back to the API using the search query that we have built in this video. In this video, we have learned about the filter method in the Lodash Collections API, and we used it to help build a search query filter for our recipe list API. We refactored some of the recipe list API code as well to utilize Lodash's chaining capability, and we used map to return an array of filtered and expanded results in our response. In this section, we have learned about several methods for managing collections using Lodash, including for each as a loop replacement, filter and map to selectively manipulate members of a collection, and reduce and count by to derive other useful values from a collection. We have built two endpoints, one to display a list of recipes and one to display a list of tags. We learned about the structure of building our client-side components for the recipe application, and we built out components to display both recipe and tag lists. We also built a filter input component to limit display of our recipes that we will later reuse to build search in the front end as well. We have accomplished quite a bit in section 2. Great work! In the next section, we're going to explore the Lodash Arrays API to work with tags in our application. We'll also begin the process of creating functionality to add recipes and tags in our front end. Hi, and welcome to section 3, which is all about creating and tagging a recipe. In the previous section, we took our first steps in Lodash, using its collection API to build a list of recipes. We added filtering of our recipes on the front end and began adding a simple search parameter to our recipe list API. In this section, we will use the Lodash Array API to manage the tags in our recipe application. We will start by ensuring we only submit unique lists of tags with a new recipe. We'll then build our API to add those tags as relations to our recipes so they can be included in tag counts and filters. After some work in the API, we will spend the last two videos of this section on the client side. We will first add the display of tags to our recipe card component, and then we'll enhance our new recipe form to allow removal of tags that have been added to our recipe. Now we move on to the first video of this section, where we will add submission of new recipes with unique sets of tags. In this video, we are going to introduce the Lodash Array API, a group of methods that are a part of Lodash tailored for working with JavaScript arrays. We'll start by solving a common problem when working with arrays, removing duplicate entries from an array. The very first thing we'll do in this video is to review our form component that will be used to enter new recipes. This form will be built upon as we go through videos throughout our course, and this will be our first look at it. We'll add form submission to our component and remove duplicate tags from our form submission before sending our request to the API. In the API, we'll add our tags to the submitted recipe and then test out our new recipe submission process. Let's get started with the form component. In your recipes client repo, check out branch video 3.1 by running the command git checkout video-3-1. Remember to run npm run dev to rebuild our app when the source code is changed. Then, in your code editor, open the component file at app/components/forms/recipes/index.js. As in our other components, we've extended our base component and created methods to get our component's template and render our component. We've also added methods to add and remove tags that will be completed in the last video of this section. The create recipe method exists but has not been filled out yet, and that's where we will start editing our component. The first thing we need to do is include the unique by method from Lodash. Below the require of the create method, add a call to require Lodash/unique by. This will include the new method in our build. Then in the create recipe method, we will get our form element that is a child of the component and get its value for title, description, and tags. Right now these are simply text inputs, so to get our tags ready for submission, we split the tag's input value by whitespace characters. What this means right now is that our tags are limited to single words, which we will improve upon later in this section. If our title and description are filled out, then we make a call to window.fetch passing the recipes endpoint along with a configuration object. This object includes a method, which in this case is a post. It also includes the headers informing the API that we are submitting a JSON payload and expect JSON in return. Then we set our new recipes attributes into the body property of the object. Since we want our tags to be unique, we are going to call the Lodash unique by method, which takes an array and a callback for each array iteration. The callback should return a value that is used to compare with the other values of the array to ensure uniqueness. Since we might have a mix of upper and lowercase tags, we want to make sure that we convert the tags to lowercase before testing uniqueness. To accomplish that, have the callback accept a tag argument and return tag.toLowercase. We then handle our resolve fetch first with a call to then to convert our response into JSON, and in our next call to then we reset the form. After saving our component file, next open up the recipes API repo and run git checkout video-3-1. This will switch to the latest API code for this section. After you have checked out the branch, in your code editor, open up routes/recipes/index.js. This is the same recipe routes file we worked on in the previous section. You'll see we now have a post route added to the file, but we have yet to include any handling of our tags. The first thing to do is add a call to unique by in our API code as well. Since we want our API to act consistently and independent of our interface, we add this functionality here to ensure the integrity of our data. We'll use the Lodash chaining method again to wrap our tags variable, run it through the same callback as our client, calling tag.toLowercase, and resolve the chain with a call to value. In our call to db.push, add the tags property and a variable to the recipe being saved to the data store. Finally, in the call to res.json, add a tags property and the tags variable to the response. Now we are able to save our tags as a unique list along with our recipe. Once we save the recipe route file, run npm run start to start the API server. In a separate console, go to your recipe client repo and also run npm run start. Open up http://127.0.0.1:9000 in your browser and open up your browser's DevTools. You'll see the new form that was added to the application where you can enter a recipe title, description, and tags. Let's test out the new form. First, enter a title, keyline pie. For the description, we'll say, refreshing pie made with key lime juice, whipped cream, and a graham cracker crust. For tags, let's enter a few. Remember, right now they're just space-separated single words. Let's enter dessert, pies, tart, and then to test out our unique by function, add pies again. Then click Add Recipe to submit the form. The form is then cleared, and you should see a post to the recipes endpoint in your DevTools Network tab. If you inspect this, you'll see the response is a newly created recipe with a new ID and an array of unique tags. Try refreshing the page and you will see the new recipe in the interface as well. In this video, we have introduced the Lodash Array API and started working with its methods to help create a form to add new recipes to our application. We adjusted our client-side component and API to remove duplicate tags from our recipes with a single line of code, thanks to Lodash. We added the tags to recipes when saving them, and then tested out our application to see the new recipe we created. In the next video, we will continue working with the entry of recipe tags by adding them to a tags node in our data store. We will establish the relationships between recipes and their tags that will then be used to drive our tag counts and display of tags in our recipe cards. In the previous video, we looked at our form component to add a new recipe to the application, and we added the ability to remove duplicate tags when creating a new recipe. In this video, we are going to take a look at how tags can be integrated into our data store and shared across recipes. We want to make sure that we don't add tags that already exist in our store, so we'll first handle separating the new tags from our pre-existing set. Then we'll create a mapping between the recipe we just created and the tags we've added to it, so we can include these tags in our recipe card later on. Finally, we'll test out our application with these changes and see how our new tags affect the existing tag totals component. To start, browse to your Recipes API repo and run git checkout video-3-2. This will get you the latest code from our previous video so you can follow along. We will be editing our recipe routes file again, so in your code editor open up routes/recipes/index.js. The first thing we want to do is replace the line of code that gets our last recipe ID. Lodash has a convenient method called last that will give you the last element of an array. The next change we want to make is to remove the chaining in our call to unique by. In Lodash, chaining is optimized for calls to multiple methods, but doesn't provide as much value for single method calls. In our video tutorials, we've applied chaining to all Lodash methods in our API. However, in the future, we will only use chaining in Lodash to apply multiple methods to an array or collection. It will help our code to be more concise and will help readability. Since we've seen a few examples of Lodash chaining now, going forward we will only use it when it is most helpful. The last change to our existing code will be to remove the tags property that is pushed to the recipe store. Since we'll manage the recipe to tag relations in another part of our store, they are not needed here. Below the call to save our new recipe, add a line to get our tags from the data store using db.getData. We want to get the last tag ID inserted like we did with recipes, so use the Lodash last method to get the last tag in the store and its ID value. The next thing we want to do is separate out the tags we've submitted that are actually new to the tag store. To do this, we'll use another Lodash array method called remove. The remove method traverses an array, executing a callback on each member of the array and removing any member for which the callback returns a truthy value. It will return an array of the values that were removed as well, so we can use it to separate out our new tags from the pre-existing tags. To do this, call remove, passing in the tags array as the first parameter and an anonymous function as the second parameter. In the function, we'll use the Lodash collection method find to get an entry that matches the tag's title, which we provide as a key value pair to the method. This will return undefined for tags that aren't in the store, so negating this method call will return true for any new tags. Next, add a call to db.push to save our new tags. The tag store structure has an ID and title attribute for each tag, so we can use the map iterator we learned about in section 2 to take each new tag and convert it to an object with a new ID and title attribute. After the call to push, remember to save the DB to write the changes. Now we have our new tags in the tag store, so let's add mappings for our recipe to the new tags. To add the mappings, let's first get our updated list of saved tags by calling db.getData. We also need to recombine our tags that we separated using remove earlier, and this is a good opportunity to show how Lodash wrappers can also proxy to native array methods. Wrap our tags variable and then call concat, passing the save tags variable as its argument. Then resolve the wrapper by calling value. To create our recipe to tag map, call the Lodash map method, passing our combined tags as the first argument and an anonymous function as the second. In the function, we create a new object and use the array bracket notation to add the recipe ID as a key and the tag ID as a value. We get the ID using find again on our tag store and then return the object we created. Below the call to map, add a call to db.push passing the recipe tags variable. Finally, follow that with a call to db.save to write the changes. After saving the changes to the recipe route file, go back to your console and run npm run start to start up the API server. In a separate console window, browse to Recipes Client and run git checkout video-3-2. This will ensure you have the latest code to test our API changes in this video. Run npm run start to start the static file server and then open up http://127.0.0.1:9000 in your browser. Open up your browser's developer tools so you can view the request and response from the API when adding a new recipe. As we did in the last video, let's enter a new recipe with some existing tags and some new tags. For the title, we'll add Texas chili. In the description, we'll add an extra spicy southwestern chili recipe. For tags, add paleo, regional, and spicy. Click Add Recipe and then take a look at your Developer Tools Network tab. You should see the post request to recipes and a response that includes the new recipe ID within a recipe object with tags included. Now refresh the page to see the recipe in the list. Note that our Texas chili recipe shows up in the list and also that the tag totals list is updated. It includes updated counts for existing tags and includes the new regional and spicy tags. Great work! We have now established the relationship between our recipe and the tags that we add to each recipe. Well done! In this video, we added to our recipes post endpoint to add new tags into our data store and to map relations between our recipes and its tags. We tested adding a new recipe with tags to the application and reviewed the updates made to our recipe list and recipe tag totals. In the next video, we will update our API's recipe list endpoint to include tags and update our recipe card component to display those tags on the front end. In the previous video, we modified our API for submitting new recipes to add new tags to our data store and established a mapping between our recipe and its tags. We accomplished this using Lodash array methods, including remove to separate new tags and last to get our most recent tag ID to auto-increment. In this video, we are going to add tags to our recipe list API using the mappings we created in the last video. We will also add the tags to our recipe card on the front end by updating the render method in our component. We'll review the template changes required to add the tags and then view the updated recipe cards with tags included. To start, go to your Recipes API directory and run git checkout video-3-3 from the command line. We will be making further edits to our recipe route file, so in your code editor, open up routes/recipes/index.js. We are going to add a new function in our route file that will take a recipe object, a recipe tags array of objects that map each recipe ID to a tag, and the tags array, all from the data store. The first thing we do is wrap recipe tags and chain a call to remove. We want to remove each recipe tag object that is keyed on our recipe's ID, and to do that we are going to use the Lodash keys method. Calling keys on an object will return an array of its own enumerable properties. In our case, the keys represent recipe IDs. In the callback, we get the ID by chaining the keys method to a call to first. We saw in the previous video that last is used to get the last value in an array. In the same way, first will return the first value. If that key matches our recipe's ID, we return true to extract that mapping from our recipe tags. The next method we chain is the ever-handy map method. We iterate the list of recipe tags that we kept, grabbing each value from the map in a similar way as the callback for remove. The difference here is we now want the value of each recipe tag mapping and not the key. To get the value of each recipe tag mapping, we call the Lodash values method, which returns an array of values for the object's own enumerable properties. Finally, we resolve the chain by calling value, and now we have an array of tag IDs for the recipe. We return from the function with a call to filter on our tags list, and in the callback for our filter, we check to see if each tag ID is in our array of tag IDs for the recipe. We use the Lodash indexOf method to search the array, which returns the array's index for that ID if it exists, or -1 if it does not. Using this method, we are able to return only the tag objects that were added to our recipe. Further down in our route file, right before we return our recipes in the response, we want to add the tags as a property of the recipe. We call our getTags function here, passing along the recipe, our tags, and our recipe tags retrieved from the data store. Once you've made these changes, save the file, and then in the console run npm run start to start the Express server instance. To see these changes in the response, open up http://127.0.0.1:3000/recipes?expand=user. Notice now that with each recipe object there is also an array of tags for the recipe. Good job! We now have the data we need to display the tags on the front end. With our API Express server still running, open up another console window and change to the recipes client repo. Run git checkout video-3-3 to get the code needed to follow along in this video, and then run npm run dev to start watching for changes to the source files. We're going to first look at the template change we made to add the tags, so in your code editor open up app/components/recipes/card/template.html. You can see below the post to buy section of our card, we've added another paragraph tag with a class of tags to hold our rendered tags. Now let's open up app/components/recipes/card/index.js to make the changes to our component to render the tags. First, let's include the Lodash for each function with our other dependencies at the top of the component. We'll use for each to iterate our tags and add them to the component within our render method. In the render method, we first create a new document fragment. Then, in the initial rendering of our template, we call for each, passing our tags as the first parameter, and a callback to add the tags to the document fragment as the second parameter. We'll use a span element to add the tag and give it label and label default classes, along with a tag class to inherit styles set for labels. We then set the text content of the span to the tag's title and wrap up the callback by adding the span to the document fragment. After the callback, we use query selector on the component's element to get the tags container we saw in the template and append the document fragment to that container. This will add the tags to the component's active DOM. Now let's save the component file and test out our results. This is also a good time to point out that when we start digging into Lodash templates a bit more, we'll refactor some of these loops to exist in the template. This will create a cleaner separation between the component's controller and its view elements. To view our card updates, from the command line run npm run start in the recipes client repo. In a browser, open up http://127.0.0.1:9000. Each recipe card now displays a list of tags that we can eventually use for further organizing our recipes. In this video, we have updated our recipe listing API to include tags that are added when a recipe is created. We also made updates to our recipe card to display those tags, opening up more opportunities in our application for filtering and organizing recipes. In the next video, we will revisit the recipe creation form we edited in the first video of this section and include the ability to add and remove multi-word tags as we create each recipe. Hi, and welcome to the last video of Section 3 in Learning Lodash, where we will take a look at adding and removing recipe tags from our recipe input form. In the previous video, we set up our recipe list API to add each recipe's related tags using map, filter, and some Lodash array helpers including first, last, and index of. We also added the tags returned from our API to the recipe card component for display in the application. In this video, we are going to take a look at adding more functionality into our recipe form component. We are currently able to enter a space-separated list of tags to add to a recipe, but that limits us to single-word tags. We also don't have a method to display or remove tags we've entered before saving our recipe. In this video, we will add those capabilities to our form component, and we'll make the necessary adjustments to our form template to store and display tags before submitting them to the API. We'll end by testing out the new functionality and creating a new recipe. To get started, first go to your Recipes API repo and run git checkout video-3-4 to get the code from our previous video. Then run npm run start to start the Express server. In a separate console window in your Recipes client repo, run git checkout video-3-4 to get the code necessary to follow along with this video. Run npm run dev to monitor for changes to the source files that trigger a new build of the front-end code. The first file we are going to edit is the recipe form component, so open up app/components/forms/recipe/index.js in your code editor. The first change we're going to make is to require the Lodash without method with our dependencies for this component. This will be used in the remove tag method within our component. Then go to the incomplete add tag method. We want to add two things in this method, a tag to save to the API and a display of that tag in the interface. To add the display, we'll create two span elements. The first will be the label to display the tag, and the second a label to remove the tag. We then query our component's DOM using query selector to get the recipe labels container and our input element for the tags. We want to treat the tags as an array like we do in the API, so we initialize an empty tags array. However, if our tags input isn't empty, we want to set those values as our initial tags. We check first using string.prototype.trim to make sure we eliminate any white space, and if we have tags, we split them on a comma. Rather than separating our tags by space as before, we'll now separate them by comma in a hidden tags form field that will be used to submit to the API. We push the tag we want to add to the array, and then join the array with a comma, setting that comma-separated list as our tag's input value. After adding the tag to our form field, we set the tag as the text content of our recipe label and set some CSS classes to inherit label styles. The remove label will contain an entity value representing the X or close button, and we use inner HTML here to avoid double escaping our entity. We also add a class to this label to style it, add the remove label to our recipe label, and add the recipe label to our display container. We need to add an event listener for the remove label as well. To do that, we call removelabel.addEventListener, passing click as our event type, a function as the second parameter that binds our recipe label and tag to the remove tag method, and false is our third parameter to not enable the capture phase on this event. Now our tag display is added to the DOM with a bound function to remove it as well. Let's move on to the remove tag method. In the remove tag method, we first want to get our current recipe tags from the input element. To do that, we call query selector as we did in add tag. What we want is a way to remove the tag from the array of tags we are about to save, and Lodash provides a very useful method for this called without. This is what we had added in our calls to require earlier. The without method takes an array as its first parameter and a value as its second. All values in the array that match the provided value are removed, and a new array is returned. This is much simpler than the typical for loop and array splicing you would have to implement to accomplish this without Lodash. We call trim in the input's value, split that value by a comma, and pass that to without as the first parameter, and the tag variable as our second parameter. We store the new array in a tags variable, and then save it back to the recipe tags input after joining on the comma. Now that we have the updated array with our tag removed, we also want to remove the tag from display. To do this, use query selector to get our recipe labels container and call remove child, passing along the recipe label element that was passed into remove tag. The last change we want to make to the component is to monitor for key press events on our text input so we can add and remove tags from the UI. To do this in the render method, after we set the component's HTML, call query selector to get a new tags input field. Call addEventListener on this input field, passing keypress as the event type and an anonymous function as the second argument. The function should take the keypress event object as its parameter. We want the enter key to trigger a tag addition, but only when the input field isn't empty. To do this, we get the value of the form field using event.target.value, again calling trim to account for whitespace. We also check the event.keycode value looking for 13, which stands for the enter key. If the enter key is pressed and we have a value for the input, we call event.preventDefault to prevent accidental form submission. Then we call addTag, passing along the form field's value, and then we get the form field one more time using querySelector to clear the value. The anonymous function should be bound to the component's this value, so we can call its methods from within using this. Now we have an event handler for our tag's input field to add a tag to display for submission. After saving the component JavaScript file, open up the component template in app/components/forms/recipe/template.html. In this form, we're going to change our visible tag input field to be named tagsInput and change the placeholder attribute to addTag and press enter. Below that field, we then need to add an input of type equals hidden, and this value will have the name of tags. This is the value that we read from and write to in our addTag and removeTag methods. Below that input, add a single div with a class of recipe labels. This will be the container for displaying our tags. Once you've made these changes, save the template. We're now ready to test out our tags input. From the console in the recipes client repo, run npm run start to start up the static file server. Browse to http://127.0.0.1:9000 to load the recipe app. Let's create another new recipe. For the title, we'll add a Mediterranean salad with a description of a great side dish for a barbecue with olives, feta, and cherry tomatoes. For tags, enter salad and press enter. Notice our tag is now added to the display and our form field is removed. Next, type barbecue and press enter. We decide this salad goes well with barbecue, but isn't really a barbecue meal, so we want to remove that tag. Click the X in the display of the tag to remove it. Let's also enter vegetarian and healthy since it's a salad. Once those tags are entered, click Add Recipe to submit the form. Refresh the page and you'll see that the recipe has been added to our list and the tag totals list is updated with our new tags. Well done! In this video, we made some improvements to our recipe input form to handle multi-word tags and to provide the ability for users to add and remove tags from a display before saving the recipe. We tested out the recipe form with new tags and verified our recipe list and tag totals are updated with the new recipe. In this section, we learned about several methods in the Lodash Array API, including remove and without to remove array elements, unique by to eliminate duplicate elements, and first and last to quickly get target elements from an array. We use those methods and others to help create a form for adding new recipes with tags to our application. We also added a tag list to our data store and added mappings of our newly saved recipes to the tags they include. We use the tags and mappings to our recipe to add tag display to our recipe card component and to update our tag totals component when new recipes are added to the application. In the next section, we are going to learn more about writing components for our application. We'll learn about extending other components and creating shared methods that will help write more robust components using less repeated code. We'll also refactor our filter input component to share some code with a search component that we will create to utilize the search API we built in section 2. We'll use Lodash object methods and utilities to help simplify the creation of our new components and help reduce the amount of boilerplate code required to write a component. Hi, and welcome to section 4 of Learning Lodash, where we will focus on writing components for our recipe application front end. In the previous section, we learned how to use Lodash array methods to add, remove, and dedupe tags when creating a recipe. In this section, we are going to start by looking at a Lodash method for extending objects. We'll use that method to build an extensible event binding system for our components. Then we will build a base input component that will be used by our existing filter input component, and we will also build a search input component upon the base input. Lodash provides ways for us to code flexible interfaces with a degree of type safety, and we'll explore that a bit while building out our search input component. Now let's move on to the first video in this section where we will learn about extending the properties of the base component. Throughout the video course, we have used modular component controllers on the front end to render our HTML and manage our events. Our events, however, are not managed in any particular structure, which will lead to maintainability issues in the future. In this video, we will create that structure and refactor our filter input component to use it. We are going to take a look at the format we want to follow for declaring events in our components. We'll refactor our filter input component to use this event declaration syntax. We'll then build a method in the base component that will bind events according to the structure that we've declared. We will utilize methods Lodash provides to make our event handler declarations more versatile. Finally, we'll test that our refactoring works as expected in the filter input component. As we've built out some of the functionality of our components, you may have noticed that we have to bind events at certain times in our component's lifecycle, either after they are rendered or after another event handler is called. This makes events difficult to track with DOM changes within a component, and it also makes it difficult for other components to be aware of events happening in other parts of the application. To help alleviate this problem, we're going to build a method in our base component that will be responsible for creating event handlers based on an events object that is defined per component. The object will have event types as its keys, and its values will consist of arrays. Each array will contain an event handler and an optional selector that, if defined, will only call the handler if the event's DOM target matches the element for that selector. This is very similar to how frameworks like Backbone manage events using a technique called event delegation. Let's start by creating an events object in our filter input component. First, go to the recipes client repo and run git checkout video-4-1. This will get you the latest code you need to follow along with this section. Also, run npm run dev so that any changes to your components will trigger a rebuild of the JavaScript source. When you have completed these steps, open the component JavaScript file at app/components/filters/input/index.js. We are going to add an events property within the call to create that is made right after the constructor property is set. This ensures that the property will exist on all instances of the component that are created within our application. The event binding that we're refactoring here is the input event that is currently bound in the init method. So the events key that we will add is the input event type, and the value will be an array. The first item in the array is the string filter items, which will be used to call the filter items method in the component. The second item in the array is a selector for our filter input element, .filter-input-form input. This ensures that the event handler will only be called if the input event originates from that input. Don't forget to remove the add event listener call that's made from init so we don't bind an event twice. Now that we have an events object created for the filter input, let's create the method that will use that object to bind the event handlers. Open up app/components/base/index.js to edit our base component. At the top of the file, we're going to add several Lodash methods. The first one is part of the Lodash Objects API, assign, which handles merging the properties of several source objects into a target object. The next two are in the lang API, isElement and isString, which, as you may have guessed, check a variable's type to see if it's a DOM element or a string. What's great about these type functions, especially the ones that check primitives, is that they will detect a primitive type even if it was created using the new syntax. Finally, add forEach, as we'll use that to iterate the events object to bind our handlers. In the base component constructor, let's refactor our type check of config.el to use isElement. Also, before the call to init, we'll set this.events using assign. We provide the component's events prototype as the target to extend, with a fallback to a plain object. The source object will be config.events. If that value is not provided, then nothing will be extended. However, this gives us the ability to have event handlers pass between components, which we'll utilize in a later video. After that line, call this.addEventListeners. Below the init method, we will add the addEventListeners method. This method simply calls the Lodash forEach method, passing this.events as the first parameter, and this.addListener as the callback for the iterator bound to the component's this context. Next, we'll add the addListener method. This method will take the event handler and selector array as its first parameter and the event type as its second. Create a handler func variable to hold the first element of the array and a selector variable to hold the second element. Then call this.el.addEventListener to bind a handler to the component's root element. The event type is the first parameter and the second is an anonymous function that receives the event object as its parameter. The function will first initialize a node variable, and then on the next line check to see if a selector was specified for this event type. If it is, then we call this.el.querySelector to get the element associated with the selector. The next line will check if the node variable is equal to event.target. If it is not, then we want to exit the handler. If it does match, or if we did not specify a selector to check against, we return from the handler with a call to our handler_func variable. This is where isString comes into use. We check to see if handler_func is a string, and if it is, we make an assumption that the string represents a method on the component. If it is not a string, we attempt to call it using function.prototype.call, passing the component's context onto the function and the event object as its sole parameter. What this does is enable us to specify either methods of our component as handlers or custom handlers that might even exist in other components. Finally, close out the anonymous handler, binding it to the component, and pass false as the third parameter to disable event capturing. Once you've saved this file, from the console run npm run start in your recipes client repo. Also, cd into your recipes API repo and run npm run start if you do not yet have that loaded. Open http://127.0.0.1:9000 in your browser and try filtering a name from the list. Notice that as you type a username, only the cards from that user will display. This is the same functionality we had before, but now we've achieved it using an event binding method that can be shared with our other components, allowing us to cleanly add more functionality into our application. In this video, we have started digging a bit more into our front-end component system to make it easier to write future components for our application. We use the Lodash assign method to create an extensible events object, and we also use two new methods from the Lodash lang API to check variable types. We refactored the filter input component to use the new event binding and tested our component after the changes. In the next video, we are going to build onto our event system by allowing multiple event handlers to be attached to a single event type using the events object, and we'll refactor our recipe form to use the events object so other components can be notified when the form is submitted. In the previous video, we looked at how to use the Lodash assign method to add properties to our components that we can override when we create them. We use that method to create an extensible events object that we can declare once per component and then extend when we create instances of each component. In this video, we are going to continue adding functionality to our event binding system by customizing the way assign extends properties of its target object. We'll use that customization to allow binding of multiple event handlers for each event type in a component. This will allow other components to assign handlers to an event within a target component. We will then refactor our recipe form component to use the events object, and after that we'll add a second submit handler to the recipe form that will be used to refresh the recipe list component when a new recipe is submitted. To start, go to your recipes client repo and run git checkout video-4-2. This will get you the code you need to follow along with this video. Once the branch is checked out, execute npm run dev. This will ensure that changes to the source files will generate a new build of the JavaScript for the front end. The first file we're going to want to edit is our base component, so open up app/components/base/index in your code editor. We're going to start our changes by adding two more Lodash lang variables to our list to check for arrays and undefined variables. These are called isArray and isUndefined. Add each one to the list of require statements at the top of the file. After adding these methods, change the require for assign to assign with, and then change the call to assign that is made in the base component constructor. Lodash provides the ability to add a customizer function to assign with that is used to determine how a value from a source object is merged into a target object. What this means is that we can alter not only the priority in which objects are extended, but the actual types of the values in the extended objects. Add an anonymous customizer function that takes three arguments: the target object's value for a given key, the source object's value for the same key, and finally the key for each property of the object. This customizer is run once for each key in the source object, and a target value will exist if we have one that we are extending. What this means is that we can take both the target and source values and combine them into an array, and this is how we'll achieve multiple handlers per event type. In the body of the customizer function, add a check for both value and source. If both are set, then we know we have two handlers, and we combine them into an array and return the value. If both are not set, then we revert to using the typical extend functionality. This is where isUndefined is used. We should check to see if the source value is undefined. If it is, we should return the target value, otherwise we must return the source. After adding the customizer function to assign with, go next to the addEventListeners method. Rather than using the forEach to call addListener directly, add an anonymous function that takes the params and event type arguments and bind it to the component's this context. With our previous behavior, the params would always be a handler function and optional selector. With our new behavior, params can now be an array of handler-selector combinations. So the first thing we do is to check if the first element in params is an array using the Lodash isArray method. If it is not, we call addListener as we did before, passing along the params and event type. If the params contain nested arrays, then we loop the params using forEach, calling addListener with each nested array of parameters. Remember again to bind this to our forEach callback to maintain context. When you're done making these changes, save and close the file. Next, we want to edit the recipe form to use the new event binding mechanism. Open up app/components/forms/recipe/index.js. We want to take the event handler added in init and make it a part of an events object we add to the call to create. This ensures the events property is added to each new recipe form instance that is created. The events object will have a key of submit, and then the value for that key will be an array with one element, the string createRecipe. This instructs the base component event handler to call the recipeForm.createRecipe method when the form is submitted. We can now delete the init method from the component since we manage the event binding elsewhere. Once you save the recipe form index file, open up app/main.js. This is where we have been creating instances of our components to add to the page, so this will be the best place to add the second event handler for our recipe form submission. Go to the bottom of the file where we create our recipe form instance and add an events object to its constructor configuration. The events object will have a single event type, submit, and an array with a single element, which will be an anonymous handler function. We've been able to submit new recipes for a while now, but we still have to manually refresh our page when a new recipe is submitted to the data store. We want to add a handler that will re-render our recipe list on submission of new recipes, and we'll do that here. The anonymous function should take the event object as its argument and then call setTimeout. The timeout is to ensure that our form submission has reached the server before we attempt a re-rendering of the recipe list. The function we pass as the setTimeout callback is list.render, the render method of our recipe list instance created above. We want to bind the method to the list component so it will maintain its context when it is called from setTimeout. The second argument will be a 100 millisecond timeout. This is a sufficient delay before refreshing our list, perhaps even too high since our API and data store reside on the same server. When you're done making this change, save and close app/main.js. Another way that we could manage this refresh is to create a custom event upon successful submission of a recipe, and then bind to that custom event in our main app file. That method would be able to handle the potential delays in a distributed system more accurately, and you could even handle error states in your form submission by events as well. You can find more info on creating custom events in the Mozilla Developer Network docs. If you're up for the challenge, try making this change in the recipe form and app/main.js file. To test our change, first go to the recipes client and recipes API repos from the command line and run npm run start. This will start the static and Express API servers. Then launch http://127.0.0.1:9000 from your browser. We'll enter a new recipe to test the automatic refresh of the recipe list. For the title, I'm going to enter Thai iced tea, one of my favorite drinks. For the description, I'll add sweet tea with additional spices. For the tags, I'll just add one, drinks. Now we're ready to add the recipe. Click the Add Recipe button and see that our new recipe appears immediately. In this video, we have learned about two new methods in the Lodash Lang API, isUndefined and isArray. We also learned about the optional customizer function that is available when extending objects using Lodash's assignWith method, and we used it to aggregate multiple handlers for events that we want to bind in our components. We refactored the recipe form component to use the events object, and we added an events object to app/main.js when we create a recipe form instance to provide a way to refresh our recipe list when a new recipe is created. In the next video, we will begin the process of creating an input component that will be used by both our filter input component and a new search input component that we'll create. In the previous video, we learned about how we could expand upon our event binding system for components using the customizer function in assignWith. We used that to aggregate handlers for event types so components could bind to their own events or the events of other components. In this video, we are going to lay the groundwork necessary to create our recipe search component by first creating a base input component that will be extended by both the filter input and search input components. We will add methods that are common to these components to our base input, and will also refactor the template to be shared as well. We will also learn how to set default properties to render the shared template and allow child components to overwrite them. Finally, we'll refactor the filter input component to extend the base input and then test our changes. Before we begin making our changes, run git checkout video 4-3 from the recipes client repo to get the latest code. After that, run npm run dev to ensure changes to any JavaScript source modules will trigger a new application build. The first thing we'll want to do is create our base input component. Let's create a directory in app/components/base called input. Within that directory, create an index.js file and open it in your code editor. At the top of the file, we will first require our base component and the Lodash create method as we have in our other components. We then want to add a new method from Lodash called defaults. This is another method in the Lodash object API. We'll talk more about defaults in a bit, but first we want to copy over what we are taking out of the filter input component. Create the base input constructor function, and from it call the base component constructor. Then assign the return from the create method to base input.prototype. As we have done before, we will pass the base component.prototype as the first parameter to create, and an object that defines the methods of our base input as the second. I want to show you a slightly different way you can create these components from within the create method. In other components, we have simply added a constructor or events property to the prototype from within create, and then added methods directly to the prototype in separate code blocks. However, we can also add methods in the object passed to create that are assigned to the base input prototype. For our purposes, both approaches work the same, but I want to show you this alternate approach as it provides a single block of code from which you could implement a module pattern in your own project, separate from what we already have using Browserify. In this object, we'll add the getTemplate method, which will return template.html like it does in the filter input. We'll also add a render method, and its contents should also be the same as the filter input method. Now let's build out an init method that will set our default properties. The parameter to init is going to be our component's config object. We want to set two properties in our component called form class and placeholder that will be applied to the template. We want to be able to provide those values in the config, but have sensible defaults if they are not provided. This is where the Lodash defaults method comes in. It works almost like an inverse of assign in that it will give priority to properties set in the target object over properties set in the source objects. For example, if my source and target objects contain the same property, the assign method would overwrite the target object's property with the one set in the source object. However, in defaults, the target object's property will remain. In our init method, we'll call defaults passing config as the target object and a source object with input form as our default form class and enter text as our default placeholder. We then set these config values as properties in the component and finally call our base component init method, passing along the config object. Now that we have a set of properties in the component to render to the template, we also want to allow overriding these properties when render is called. To do this, modify the data object that is passed to the template by calling defaults again. Pass the data variable as the first parameter, falling back on an empty object if no data was provided. The second parameter to defaults will now be an object that sets both the form class and placeholder property defaults to the component properties we set in init. This gives our component the flexibility it needs both when it is created and when it is rendered within our application. At the bottom of our base input JavaScript file, set module.exports to the base input constructor so other modules can require it. Once you've saved the base input file, you will want to move the filter input template to its new location. Move the template from app/components/filters/input/template.html to app/components/base/input/template.html, and then open it in your code editor. The placeholder property is already used in the template here, but not the form class property. To add that, replace the filter input form class with a Lodash template variable called form class. This change will enable us to override styles for various input components by changing a single property when we create or render the component. In Section 5, we will talk more about templates in depth, including the types of template delimiters that you can use when inserting strings. The next thing we want to do is refactor our filter input component so that it extends our base input component. After you save the template we just edited, open app/components/filter/input/index.js in your editor. The first refactor is that we no longer need to require the base component, we now need to require the base input. Update the require statement and assign it to a variable called base input. Next, in the filter input constructor, change the call to the base component constructor to call the base input constructor. Also, in the call to create, pass base input.prototype as the first parameter so our component will inherit the methods we created previously. The filter input init method currently doesn't call any parent init method, so it would not inherit the property assignments that we created in base input. To fix this, simply add a line to init to call base input.prototype.init, passing along the config object. The last refactor this file needs is to remove the getTemplate and render method definitions. Since we now inherit base input, we want to use the methods defined there. After making these changes, save and close the file. The final change we need to make is to app/main.js. Open that file in your editor and find where the recipe filter is created. Rather than passing the placeholder directly to render, we're going to pass it to the constructor in the config object. Note that we could still pass it to render if we wanted, we just don't need to in this case. Also, add the form class property to the config, setting it to filter-input-form as we had previously in the template. Once you save these changes, we're ready to test our recipe filter. From the command line, go to the Recipes API repo and run npm run start. In a separate console window, go to the Recipes client repo and run npm run start. This will get both the Express API server and static asset servers running. Open up http://127.0.0.1:9000 in your browser. Note we still have the recipe filter input with the placeholder filter recipes by user. Right-click on the input and select Inspect Element to open up the developer tools. Notice that the parent form element has the class filter input form as we defined in the component's configuration. Next, type one of the usernames on a recipe card. Note that we still have the filtering functionality provided by the filter input component, while we also have the reusable templating functionality provided by the base input component. In this video, we created a new base input component that will share properties with both our filter input and search input components. We used the Lodash defaults method to define default properties for a base input instance that are rendered to its template for display. We refactored the filter input component to extend our new base input component, and we verified our recipe filter works with the shared template functions and properties created in the base input. Great work! You've written your first extensible component for our application using Lodash. In the next video, we will create a new search input component that will extend our base input and communicate with our API's search capability to render custom lists of recipe cards based on search terms. Hi, and welcome to the next video in our video course, Learning Lodash, where we will build out the search input component for our recipe application. In the previous video, we created a base input component that contains properties and methods shared by both our recipe filter and the recipe search we are going to create. We used Lodash to establish default properties for all input components that inherit from the base input, and we allowed overrides of certain properties when a component is rendered. In this video, we'll start by reviewing the application changes made to accommodate the search input. We will then build the new search input component and add it to the list of components rendered in our application. We will use our event binding system developed earlier to handle the search and query our API for recipes. After we build the component, we'll test out our new search functionality in the browser. Before we start, go to the command line in the Recipes client repo and run git checkout video-4-4. This will get you the latest code changes required to make room in our UI for the search input. Run the npm run dev command to track changes in the source files. The first change made was to the index.html file. The header columns were adjusted to make room for a div element that contains an input selector component. There was also a recipe search container added to the column containing the recipe filter container. The next change was in main.js. where we add the recipe input selector component to the page. The final change was the addition of the recipe input selector component added in app/components/recipes/inputs/selector/index.js. This component will toggle between search and filter inputs to provide the user two modes for finding a recipe that they're looking for. Now that we know the changes required to add our recipe search component, let's build the component JavaScript controller. Create a directory at app/components/recipes/search, and in that directory, create a file named index.js. As we did with the filter input component, we are going to extend the base input, so that is the first module we want to require. We also want to require the Lodash create method and then two new methods from the Lodash object API that we'll discuss shortly, the get and result methods. Below these lines, create the search input constructor and call the base input constructor from within it. After the constructor, we want to call create and set the search input.prototype to inherit from base input.prototype, extending it with a constructor property set to search input and an events object. Note that this pattern is the same that we've used for our other component controllers so far, and we will build the component methods from within the call to create like we've done for the last few components that we built. For the events object, we are going to create one key for the submit event, and the handler for that event will be a method called search recipes. We want to execute this event when the search input form is submitted, so we'll add a selector for that class to filter the delegated events in our component. The search recipes method will take a single parameter, the event object. However, we might want to allow other components to call this method, so we're going to use the Lodash result method to operate on the event object. The get and result methods work on an object using a string property parameter that can be namespaced using dot notation and will attempt to resolve the value of that provided property. What this means is that you can retrieve deeply nested values within an object that may or may not exist without getting runtime errors when trying to access properties of a non-object. The primary difference between get and result is that result will check to see if the property is a function, and if it is, result will call the function. The way we'll use result will pass the event parameter as our first argument and the string prevent default as our second. If the event object exists, the default event handler will be canceled. If the event object does not exist, the prevent default property will not resolve and therefore nothing will happen. After this line, we want to get the form element that contains our search input, so we call query selector on our component element, passing the form tag as our selector. On the next line, we're going to combine the use of get and result to extract the input's value. We first call get, passing the form variable as the first parameter, and elements.baseinput.value as our second. If the form and search input value exists, the resolver will return the text entered, otherwise it will return undefined. We want to be able to handle empty strings as well and call trim on that value, but we can't ensure we actually have a string as our value. This is where result comes in handy again. Let's wrap our call to get with a call to result. The first parameter is the return of our call to get, and the second parameter is the trim property. If the return value is a string, it will be trimmed. Otherwise, the function will resolve to undefined. This is a great way to encapsulate property and method accessors that may exist without having to excessively use guard and default operators. Finally, we check that we have an input value, and if we do, create a custom event called recipe search, passing the input term as our event detail value. For more information on creating custom events, take a look in the Mozilla Developer Network documentation located at https://developer.mozilla.org/enus/docs/web/api/custom event. There is also a custom event polyfill available on GitHub at https://github.com/crambule/custom event polyfill if you would like to add support for Internet Explorer to the application. At the bottom of the file, set module.exports to the search input constructor so it can be included by other modules. Once you save the new search input component controller, open up app/main.js to add the component on the page. Let's first require our new component and assign it to a variable recipe search. We then create a new recipe search instance and assign that to a search variable. The configuration object we pass to the constructor will have an EL property of the recipe search container added in the index file. The form class property will be search-input-form, and the placeholder will be search recipes. Here we'll also add an events object that will listen for the custom event we created in the search input component. The handler for the custom event will get the search term that was added to event.detail and then call recipe-list.render, passing along the term. Now in main.js you can see two samples of handling form submissions by re-rendering the recipe list. The previous handler we created using the submit event, and the new one uses a custom event. After adding the component to main.js, save that file and then open up app/components/recipes/list/index.js. We now expect the ability to pass a search term to the recipe-list.render method, so let's incorporate the term. At the top of the function, first add a term parameter to the function declaration. Then on the first line, set a URL variable to the URL we previously passed directly to fetch. After setting the URL, we want to check if a term has been passed. If a term exists, we append it to the URL variable, making sure to encode the term for use in a query string. Finally, we replace the URL string being passed to window.fetch with the URL variable we set up. Once you've completed these changes, let's test out our search functionality in the browser. Before launching the browser, let's make sure our API and client servers are running. From the command line, go to your Recipes API repo and run npm run start. In a new console window or tab, go to your Recipes client repo and run npm run start. This ensures both server and client are running to test the search functionality. In a browser, open up http://127.0.0.1:9000. Notice at first the change in the header. Where we used to have just a filter input, we now have a search input by default with a dropdown. In the dropdown, we can choose either search or filter. Choosing one will display the associated search or filter input components on the page. This dropdown is the recipe input selector component that was prepared in advance of this tutorial. Now with the search input selected, type in a term from one of the recipes in your list and press the enter key. The recipe list will update, displaying only the recipes that have a description containing the search term that you provided. You can either search all recipes again, or if you wanted to filter by username in this new list, you could select the filter input to start typing usernames. And with that, we've added search to our application. In this video, we created a search component to query our data store for recipes that match parts of a description. We reviewed the necessary changes required to add the component to the page, and then added the search component with a custom event handler. While making these changes, we learned about two Lodash object methods to get deeply nested properties in a way that won't throw unexpected errors. We finished by testing out both search and filter functionality within our application. In this section, we have added new components into our application, including base input and search input components. We made our client-side component system more robust with an event binding system that all components inherit, and we accomplish these tasks using methods from the Lodash object and lang APIs to simplify property and method access. In the next section, we are going to begin enhancing the display of our recipes by digging more into Lodash templates and string methods. We'll also begin to look more into our application's users and how we can incorporate the display of user details in our application. Hi, and welcome to Section 5, where we will build out the pieces of our application to display recipe and user details. In the previous section, we added an event binding system to our client-side components, and we learned how to extend objects using Lodash. In this section, we will start by refactoring some existing API code to use Lodash for escaping and trimming input strings, and we'll add these functions to our client-side code as well. We will also build out templates to display recipe details when a card is interacted with, and improve our existing templates to truncate recipe details. We'll wrap up the section by adding more user data to our application and adding some markup to display that user data. We'll accomplish these tasks using methods introduced in the Lodash string API. By the end of this section, we should have interactive recipe cards for our application. Now let's move on to the first video of this section that deals with escaping, trimming, and padding strings using Lodash. By the end of this video, you will have learned several new Lodash string methods, and you will have built the base to import Lodash methods into a template. In this video, we will refactor our API and client-side code for searching and filtering recipes and use Lodash to properly escape the input. We'll also refactor several sections of this code to use Lodash's trim method. We'll then add code to our components to allow Lodash methods to be called from templates. To wrap up this section, we will add string padding to our recipe card template. To follow along with this video, first go to your Recipes API repo and run git checkout video-5-1. In a separate console window, go to the Recipes client repo and also run git checkout video-5-1. Once that is complete, from the Recipes client repo, run npm run dev to track source file changes. Once you've updated your repos, in the Recipes API repo, open app/routes/recipes/index.js. We've added basic search functionality to our API, but we missed an important step in creating our search. Since our search terms are used in a regular expression, we want to escape characters that are reserved for expressions. Trying to write an expression to test for expression characters is certainly error-prone, and it is also a function that would probably need to exist for multiple modules in your application. Thankfully, Lodash provides a method to accomplish this in its string API, aptly named escapeRegex. Go to the line where the regular expression object is created and wrap the Q variable with a call to escapeRegex. Let's not stop with only that update. Lodash also has methods to trim strings, including trim, trim left, and trim right. The benefit of these methods as opposed to their native counterparts is that all three methods take an optional second parameter indicating the characters that you want trimmed. It will default to trimming whitespace, but if you use the second parameter, you can trim other characters from a string. We are going to use trim to wrap rec.query.q, and we can also replace the call to string.prototype.trim on line 52 with the Lodash trim method. Once you've saved the recipe route file, from the command line in your Recipes API repo, run npm run start. This will start the Express API server for us to test. However, before we test, we'll make some changes in our Recipes client repo. We also need to add an escape to our filter input component. Otherwise, entering regular expression characters in your filter will cause a JavaScript runtime error. First, let's open up app/components/filters/input/index.js in your code editor. At the top of the file, after the other calls to require, add requires for the string methods escapeRegex and trim, setting the module imports to variables of the same name. We'll add these to the filterItems method where we assign input.value to the text variable. Wrap input.value with a call to trim, and then wrap that with another call to escapeRegex. This will ensure that your text input does not cause any runtime errors if it includes reserved regular expression characters. Also, we can refactor the call to the native string trim in filterItem to use the Lodash trim method. While using the Lodash trim instead of a native trim method may not have any perceivable difference in output, it is nice to have access to string utilities that are tested and work consistently in all browsers. Once you save the filter input component, let's turn our attention to templates for a moment. We currently have the ability to render data to a template using Lodash, but more complex templates need to be able to run JavaScript and call Lodash methods. Since we include all our Lodash modules using CommonJS requires, they are not available at runtime in a compiled template. However, Lodash provides the ability to import variables and functions into a template when it is compiled using a settings object. We're going to enhance our base component to check for methods that our component wants to pass into a template and compile the component's template with those methods available. First, open up app/components/base/index in your editor and go to the base component constructor. The constructor currently assigns a compiled template to this .template, but does not allow any settings to be passed to the Lodash template method. Let's refactor this by first creating a settings variable set to an empty object. Then, check if a template imports property is set for the component. If it exists, set the settings.import object property to this .templateImports. After that check, create the template, passing the settings object as the second parameter to template. Now we have the ability to set functions in our component that can be passed to a template, allowing for more complex template creation. To try this new feature out, open up app/components/recipes/card/index.js. We'll require one more Lodash method, pad, which will take a string and a length parameter and pad the string with a character until reaching the specified length. Like trim, the pad method also has pad left and pad right variants, and can also take a parameter specifying what character to use in the padding. We are going to put pad to a pretty simple use here, to provide the spacing in our template before the user's username. In the assignment of recipecard.prototype, create a template imports object. The object will have one property, pad, and the value of that object will be the Lodash pad method required above. After saving the recipe card component, open up its template at app/components/recipe/card/template.html. We're going to replace the current posted by string with a call to pad. Since the string is 9 characters long, we'll pass 10 as our second parameter, so a single space is always guaranteed. While this particular example is somewhat anecdotal, you could perhaps see a circumstance with arbitrary localized strings of various lengths that need to be included in a template with padding. Now that we've made this change, we have the first sample of including a Lodash function inside a template that is compiled using Lodash. Once you save the template for the recipe card, run npm run start from the command line within your recipes client repo and open up http://127.0.0.1:9000 in your browser. You'll see the posted by string properly padded, but more importantly, you'll be able to use strings in the filter and search inputs without causing any runtime errors in the JavaScript. Try entering some regular expression characters into both. You should be able to see the cards disappear since no terms match those characters, but your browser's console should remain clear. The same should also be true of the console running the Express API application. In this video, we have learned several new Lodash string methods for escaping strings to use in regular expressions and for trimming and padding strings. We added the ability to import Lodash methods into our templates using the template settings parameter that Lodash template provides. We also tested out the use of Lodash methods in a template while using the pad method to format text for the recipe card. In the next video, we are going to build out the contents of a recipe details template and learn about a method to format our recipe description to fit well within the recipe card container. In the previous video, we learned how to trim and pad strings using Lodash, and we learned a Lodash method to escape regular expression characters and strings. We also created a way for our client-side components to declare Lodash methods that they would also like to import for use in their templates to enable the creation of more complex templates in our application. In this video, we are going to take a look at how we can add images to our recipe cards and make room for those images by truncating our recipe descriptions. We will first need to accept image URLs in our data store, so we will add that property to our API. We will then update the recipe form component on the front end to add an input for recipe image URLs. We'll use Lodash to add optional images to our template and make room for a View More button that will eventually be used to view additional recipe details. To get started, from the command line, browse to the Recipes API repo and run git checkout video-5-2. In a separate command line window, go to the Recipes client repo and run git checkout video-5-2. This will ensure both repos have the latest code to follow along with the video. In the Recipes client repo, run npm run dev to track changes made to the JavaScript source files. After you have checked out the correct branches, in the Recipes API repo, open up routes/recipes/index.js for editing. The changes here are minimal. We need to add an image property that will be provided in the request body to the data store, and then return that property in our response. First, add an image variable and set that to the property post.image. Second, in the call to db.push, add the image property to the object being saved and set its value to the image variable. Finally, at the bottom of the function, in the call to res.json, add the image property to the object being returned and set its value to the image variable. Once you save these changes, go to your command line window. From the Recipes API repo, run npm run start to run the API server. We'll make the remaining changes in the Recipes client repo. Go to your editor and open up app/components/forms/recipes/index.js. We need to add the image as an input in our form and then save it to the API with our post request. In the createRecipe method, add a variable called image and set it to the value of form.elements.image.value.trim. Next, in our window.fetch request, add a property called image to the request body that is stringified and set its value to the image variable. This ensures that any form value that we might have for the image will be sent to the API. Once you've saved your changes to the recipe form controller, let's review the changes to the recipe form template in app/components/forms/recipes/template.html. I've added a new section element below the description that includes an input for an image URL. Something you would likely want to add to an application such as this is the ability to upload an image, But for our case though, a URL reference will work well for demonstration. After reviewing the template changes, we'll look next at the recipe card components controller. Open up app/components/recipes/card/index.js in your editor. We're going to add two Lodash methods to the requires at the top of the file. The defaults method, which we've used before, and the truncate method, which is a part of the Lodash string API. In our template imports property added in the last video, add a new import for the truncate method, setting its value to the variable created above. The next change we'll make is in our render method. When calling the template function, we may not always have an image. Notice that it was not a required field. So we'll use the Lodash defaults method to ensure a default value is passed to our template. This will prevent an error from an undefined variable when our template function is called. Pass the data variable as the first parameter and an object as the second parameter with a property called image. This will be set to null so no image will be displayed on recipes that do not specify one when they are created. Once you've made these changes, save the recipe card controller. The last file we'll edit is the recipe card template, located at app/components/recipes/card/template.html. In the card title container, we first want to add a conditional block to display the recipe image. To do this, we'll use the evaluate delimiter, which is used to wrap blocks of code to be executed in the compiled template. Open the evaluate block with an angle bracket and %, and add an if check for the image property. Add the opening brace to the if statement as well, and then add the closing delimiter, which is also a % and closing angle bracket. Below that line, add an image tag, setting its source attribute to the image property and its alt attribute to the title property. Below the image tag, open up another evaluate delimiter and add the closing brace for the if statement started above, followed by the closing delimiter. In the card content block that follows, wrap the output of the description property with a call to truncate. The truncate method takes a string as its first parameter, and either a length to truncate or an options object as its second parameter. The options can include a length to truncate, the characters to show at the end of the truncation, and a separator expression to use when truncating. Here we'll just use the default options and pass a length of 60 as our second parameter. Once you've saved this template, go to the command line in your recipes client repo and run npm run start. This will start the static file server. In a browser, open up http://127.0.0.1:9000. You should see the new recipe image URL input in the form at the bottom of the screen. Let's try adding a new recipe. We'll go with the favorite here with the pizza recipe. For the description, we want something long enough to truncate, so we'll add excellent homemade pizza recipe that is topped with ham, cheese, and fresh tomatoes. The URL for the image will be one that is already hosted locally at 127.0.0.1:9000/assets/images/pizza.jpg. And for the tags, let's add kid-friendly. Once the form is submitted, you should see the new recipe with an image added to the page. You'll also see there is now a truncated display of the recipe description. In this video, we have added the ability to show a preview image in our recipe card. We made the necessary adjustments to both the API and the front-end code to add an image to the recipe, setting a default image value for the template using Lodash. We also added truncation to our recipe description with the Lodash truncate method. Good work! You're well on your way to writing more complex Lodash templates. In the next video, we will create the template to display the recipe details. When creating the details template, we'll learn about integrating more complex constructs into our templates using Lodash. In the previous video, we looked at how we could integrate images into our recipe cards and also how we could truncate the display of our recipe descriptions using Lodash. In this video, we are going to create the recipe details template that the user will see when they click a View More button. A modal view window has been created, as well as a method to inject the recipe details template into the modal. We start out by looking at those changes in the recipes client repo. We will then add the recipe details template to our recipe card component and add the code necessary to include the details template into the modal window. After that, we will create the recipe details template using Lodash methods to build out the display of our recipe data. Finally, we will remove some parts of our recipe card template that are now displayed in the recipe details. To begin working, you will need to get the latest code for both the Recipes API and Recipes client repo. On the command line in your Recipes API repo, run git checkout video-5-3 to get the latest code, and then run npm run start to start the API server. In a separate command window from the Recipes client repo, run git checkout video-5-3 to get the latest code. A new dependency has been added to this branch called picomodal, so run npm install to get the latest dependencies. After the dependencies are updated, run npm run dev to track changes made to the JavaScript source files. The first thing we want to do is to take a look at the changes made to include the modal window for displaying recipe details. Open up the recipe card component controller at app/components/recipes/card/index.js. Notice that there are two new dependencies. The first is the Lodash parseInt method, which enforces the ES5 implementation of window.parseInt, and the second is picomodal, which is a freestanding library to create modal windows using only JavaScript. There is an events property added to the prototype for the component, which will call a method named showMoreDetails when a viewMore link is clicked. There is also a modal property added to the prototype, which is a reference to the modal instance that is created by the picomodal library. The showMoreDetails method gets the recipe ID from a data attribute in the card template and then makes a call to window.fetch to get the full details of that recipe. After the promise to return a JSON serialized object is executed, the callback checks to see if a modal instance has been created. If there is a modal instance for the component, it will be reused. If there is no modal instance, a new picomodal window is created with a content property that we're going to populate. After the instance is created, we call the show method on the modal window to display it on screen. If you'd like to learn more about the picomodal library, then take a look at the following link, where there are more details about API options, custom styles, and more. Now that we've reviewed the changes required to show a modal window, let's start adding our template. In the require section at the top of the file, add the template method from Lodash. We'll use this method to compile a new template within the card for displaying the details of the recipe. After that, go to the template imports and add the forEach method to the object. The forEach method is pretty common to see in templates, where it is great for rendering dynamic lists. We will use it in our template to display both recipe tags and ingredients. Next, we will add an init method to our card, which takes a config object as its parameter. In the init method, set a property on the component called detailsTemplate and assign to that property a call to the template method. The first parameter will be a require of the template details.html, and the second parameter will be a settings object that includes our template imports as the variable imports of the template. After the assignment of the details template, call the base component.prototype.init method, passing along the config that was provided as a parameter. Next, go to the showMoreDetails method that we reviewed earlier. In the creation of the modal window, set the content property to this.detailsTemplate and pass to that compiled function the recipe returned in the API response. As we did in our render method, we need to account for recipes that have no image defined, so wrap the recipe object passed with a call to defaults. Pass the recipe object as the first parameter and an object with the property image set to null as the second parameter. This will render the template with our recipe details to the modal when it is created for the first time. After you've saved the recipe card controller file, let's create the details template. Create a file at app/components/recipes/card/details.html. We are going to create a container for the details template first with classes of modal and recipe details. In that container, create two div elements. The first one will have a class of modal title and the second a class of modal content. In the modal title div, add an h1 tag and set its text content to the recipe title. Notice here we use the Lodash interpolate delimiter, which will print out any variables provided in the data object. On the next line, we are going to add an evaluate block with delimiters as we did in the previous video, checking for an image variable. If we have an image, we render a div element with a class of modal image, and in that div we add an image element. Set the source attribute to the image variable and alt attribute to the title variable. After that line, we'll close out the div and add the closing evaluate block. Next, in the modal content div, we will add a paragraph tag with a description as its contents, followed by the username of the user that created the recipe. The description will be wrapped in Lodash escape delimiters. The escape delimiter will escape its interpolated string, converting HTML characters to their entity equivalents. After adding the description variable, add a site element with a class of small, and then add a pair of interpolate delimiters. We're going to use the pad method to pad the posted by string, and then append to that string the user.username value. Notice here that we are able to use simple JavaScript concatenation within our template delimiters. The last pieces we need to add to our templates are the ingredients and tags. After the paragraph tag containing the description, add an h5 with the title of ingredients. Below the h5, add a ul tag with a class of list flat and close out the ul tag. Within these tags, create a new block with evaluate delimiters. This pair of delimiters will hold a call to for each, with the first parameter being the ingredients variable and the second parameter a function that takes a single ingredient, which we'll call I. Add the opening brace for the loop before the closing evaluate delimiter, and then on the next line add an li tag with the value i.title displayed in a pair of interpolate delimiters. After that line, create another pair of evaluate delimiters and close the for each loop before the closing ul tag. For the tags, we'll do something very similar using for each. After adding an h5 element with the title tags, add another pair of evaluate delimiters with a for each loop. Pass the tags variable as the first parameter and a function that accepts a single tag named t as the second parameter to for each. After the evaluate block, add a span tag with classes of label, label default, and tag. For the span element's text, add t.title and a pair of interpolate delimiters. Finally, close out the for each loop within another pair of evaluate delimiters. Now that we display tags in our details template using evaluate delimiters and for each, we don't need to display these on the recipe card. Let's save our template, then reopen the recipe card component. In the render method, delete the creation of the document fragment, as well as the for each loop that adds span tags to the element. Having this logic in the template makes for a much cleaner separation of concerns. Our controller can deal with user interaction, and our template can hold any logic specific to the display of data. After you save the recipe card component, open the recipe card template at app/components/recipes/card/template.html. We can now remove the paragraph tag with a class of tags since we no longer populate this element in the card. After you save the recipe card template, go to the command line and run npm run start from the recipes client repo. In your browser, open up the following link to view the application. Notice now that we no longer have the tags on display in our cards, and our images help to entice the user to find out more about the recipe. Try clicking on the View More button. You'll see a modal window appear with the full details of the recipe, including recipe ingredients and tags. In this video, we created a template for displaying recipe details from scratch using JavaScript conditionals and loops through Lodash. We are able to remove extra display logic from our recipe card components controller, and we now have a recipe card that the user can interact with to find out more information about a recipe. In the next video, we're going to add some additional markup to display user details and integrate that into our recipe card component as we did with the recipe details. It looks great to see everything coming together. When we're done with the next video, we will have completed most of the work involved in building out our recipe cards. Hi, and welcome to the last video in our section on displaying recipe and user details, where we will focus on adding user information into our recipe details template. In the previous video, we added a template for displaying recipe details in our application and added the template into our recipe card event handler when displaying a modal window. In this video, we are going to take a look at adding the recipe creator's information to our recipe details template. To do this, we are going to create a container in our template that the user can show or hide using links in the template. Then we'll create an event handler that toggles a class on our container that is styled by our CSS. We'll wrap up by adding the event listeners to our modal window to respond to users clicking to show or hide the recipe creator's information. The first thing we'll need to do is get the latest code. Go to your recipes API repo and run git checkout video-5-4. This will get you the data store updates that include more user data for our template. After checking out the branch, run npm run start to launch the Express API server. In a separate command line window, go to your recipes client repo and run git checkout video-5-4. This will get you the CSS changes used to show and hide the user's details, which we'll review shortly. After checking out the branch, run npm run dev to track changes to your source files. The first change we are going to make is to add the recipe creator's details to our template. Open up app/components/recipes/card/details.html in your editor and go to the section inside the modal content div where the user.username property is displayed. We are going to wrap the display of the username with a link tag with a class of recipe user. In just a bit, we will add an event handler to this link that will open the recipe creator's details. Below the paragraph tag, create a new div element with a class of modal content user. The first thing we'll add to this container is a link with classes of write, which is used to display the link on the right side of the container, and close user. We will later bind an event handler to this link that will close the recipe creator's details. After the link to close the user details, add an h5 tag to display the username and avatar. In this h5 tag, create an image tag with a source attribute of user.image and an alt attribute of user.username. Both properties should be contained within interpolate delimiters. Below the image tag, add the line about user.username, also in the template delimiters. After the h5 tag, create two div elements. In the first div, add a strong tag with the text name, and then add two pairs of interpolate delimiters. We're going to concatenate the user's first and last name here, but we want to also format it to make sure it is properly presented. We can use the Lodash capitalize method to capitalize the first letter of a word, so we'll add that method within each pair of delimiters, passing user.firstname to the first call and user.lastname to the second call. You could also add a call to two lowercase for each property to ensure that we have a properly formatted first and last name. In the second div element, add a strong tag with the text email, and then add a single pair of delimiters to display user.email. After the div, we'll add another paragraph tag with the word contact, a space, and then a mail to link that can be used to contact the user. In the mail to link, the text will be the user.username property, and the href attribute will be the user.email property. After this line, we can close out the modal content user container element. After saving the details template, the next thing we want to do is create the event handler to show and hide the user details container. Open up the recipe card components controller at app/components/recipes/card/index.js. We will add two more Lodash functions for our dependencies here. The first is the filter method from the Lodash collections API, which we'll use in our event handler. The second is the capitalize method from the Lodash string API, which we just demonstrated use of in the template. After adding the two methods, update the template imports for the card to include the capitalize method in the template. Next, we are going to add a method on recipecard.prototype called showUserDetails. This method should take a single argument, the event object for the click event that we'll set up shortly. We are going to create two variables called userElem and modalElem. The modalElem variable should be set to this.modal.modalElem, which is a method from the PicoModal library used to get the modal container element in the DOM. We want this method to handle clicks on both the recipe user link to open the user details and the close user link to close the user details. To do this, we'll create two if conditions. The first will check to see if event.target.className contains the text recipe user using the indexOf method. If that string exists within the element's class name, we'll prevent the default click handler and then use query selector on the modalElem variable to get the user details container we created earlier. We'll add the active class to the class name by first splitting the class name into an array on spaces, then calling concat to append the active class, and finally rejoining the array on a space. After that, we will return from the handler since we don't need to go any further within this method. The second if condition should check to see if event.target.className contains the text close user, again using the indexOf to search the string. If the string exists in the element's class name, we will prevent the default handler, get the modal content user container as we did before, and then set its class name using the Lodash filter method. We need to remove the active class, but we are unable to know where in the class name string it may exist. So we can split the class name into an array on spaces as we did before, and pass that to filter as the first parameter. The filter function will take a single class name parameter and return true if the class name is not equal to active. After the call to filter, we will join the array on a single space, which will set a class name with all instances of the class active removed. The last change we'll make in the recipe card component is where we create the modal instance. We need to attach the showUserDetails method to an event. However, we cannot use the events object in our controller since the modal instance is appended to document.body. The Pico modal library has a convenience method called modal_element that we used before, and we can use it again here to add an event listener for the click event. Add a call to add event listener to this.modal.modal_element, setting the event type to click and the handler to this.showUserDetails, calling bind to bind the component's context to the handler. After saving the recipe card components controller, go to your command line in the recipes client repo and run npm run start. In your browser, open up the following link and then click on View More to view additional recipe details. You'll notice the Posted By section of the details is now a link. Click it to open the user's details. You'll see an avatar, name, email address, and link to contact the user. On the right side of the modal, there's a close link. Clicking that link will close the user details container. Enjoy the unique avatars provided here. They come from Adorable Avatars, which you can check out at avatars.adorable.io. In this video, we completed the display of our recipe details by adding the user details of the recipe's creator. We used the Lodash capitalize method to format the user's first and last name, and we used the filter method to remove a class used to display the user details in the template. We wrapped up the video by adding an event handler to our modal window to show or hide the recipe creator's details based on what link was clicked. In this section, we have explored parts of the Lodash string API and learned more about building templates in Lodash. We built templates to display recipe and user details and added events to our recipe cards to display those details, adding more interactive elements to our application. We also learned how to use Lodash to truncate and format strings for display, and we learned how to add Lodash methods to our templates for writing more complex display logic. In the next section, we will cover more Lodash utilities used in our application as we finalize our recipe details and create a way for users to log into the application. Hi, and welcome to Section 6, where we will review other utilities used in our recipes application. In the previous section, we used methods in the Lodash string API to help format our recipe cards. We also added Lodash functions into our templates, thereby enabling the creation of more complex templates. In this section, we will start by adding a route to our API that will allow a user to log into the application, and we'll use Lodash to track the user's login time. We'll also create a login form for our front end and hide parts of the application based on the user's login status. After handling login, we'll turn our attention to recipe details, adding the date created and precise amounts for each ingredient required. We'll make updates to our API and recipe form to allow the user to add ingredients when creating a recipe. Now we move on to the first video of this section that deals with adding a user login route to our API that will also mark the timestamp of a user's login. In this video, we are going to take a look at how we can log a user into the application using basic HTTP authentication. We'll review Express middleware used to parse a basic auth header and validate a client auth token. We'll then write the internals of the login route for our API, generating a token and timestamp for the user upon successful login. We'll use Lodash to retrieve the user from our data store and generate a timestamp for their login. We'll wrap up the video by testing the login route we created. Before we get started, let's make sure we have the most recent code checked out. From the command line, go to your recipes API repo and run git checkout video-6-1. This will get you the latest code you need to follow along with the video. After you check out the branch, you'll need to run npm install to install a third-party package added for this video. We'll be working in the recipes API repo to create a route to log the user into the application, but first let's review how we are going to handle authentication. In your code editor, open up app/utils/auth.js. This module defines two functions for managing authentication in our Express API. The first function manages validating the contents of a basic HTTP authorization header with the help of a Node module we added to our dependencies called basic auth. The basic auth module will parse the base64 encoded auth header and extract from it both name and pass properties. we use those to search for a user in the data store using the Lodash find method, passing the username that we would like to validate. If we find a user in the store and the stored password matches what was in the encoded header, the middleware will assign the user to the request object and then delegate to the route by calling next. If we cannot find a user or if the passwords don't match, we set a www authenticate header and return an HTTP status of 401 for unauthorized access. The second function will handle validating a token that our login route will provide to the client. It validates the token by checking the data store for a matching user. As we did with the basic auth middleware function, we use the Lodash find method, passing the token that we extracted from the HTTP authorization header. If we are able to get a token from the header and find a user for that token, the middleware will assign the user to the request object and then delegate to the route by calling next. If there is no token provided, or if there is no user for that token, we return an HTTP status of 401 for unauthorized access. Now that you've seen the functions our API will use to validate users, let's build the route that will log the user into an application and provide them a new token. Open the login route file at routes/login/index.js. This route will need to generate both a token for the client and a timestamp for the login. We'll use that timestamp later on to provide a last login display for the user. Let's start by including the dependencies we'll need to create the route. We will need the auth middleware that was shown previously to validate the user's login credentials. We'll also use Lodash within our code, Node.JS and DB to access our data store, and the Node.js crypto module to generate a token. The route function has been created, but we want to add in our basic auth middleware function to validate the user based on the header. We'll add this as the second parameter to the route. Start the function by creating a new instance of JSONDB and assign it to a local DB variable. Next, get a list of the users in our data store by calling db.getData and assign that list to a local users variable. After we create these local variables, we'll want to create a function to reuse if we reach any error conditions within our route. Create a function called sendError that we'll call res.status, passing a status code of 500, and then chain that to a call to res.json, passing an object with a generic message that we were unable to log the user into the system. We'll use this method if we are unable to generate a token or if we're unable to update the data store with the generated token and login timestamp. Below this function, we'll use the Lodash findIndex method to locate the position of the user in our list of users and store it in a variable I. The findIndex method works similar to the find method, but will return the index of the element found in the array instead of the element itself. After we get the index, call a method in the crypto library called randomBytes that will generate a random data string and return that to a callback through a buffer object. We pass the desired number of bytes to generate, and the callback is our second parameter. The callback takes two parameters, an error object and a buffer object. Let's name these parameters error and buff respectively. In the callback, use an if statement to make sure we do not have an error object. If there are no errors, we'll attempt to write the token and login timestamp to the data store. To do this, we'll use another handy Lodash method called attempt. Normally, we would need to wrap a write to the data store in a try-catch block, since there are errors that can be thrown within that module. However, the attempt method abstracts that away for you and will call the provided function, returning either the function's return or any error that is caught during execution. This is accomplished through a try-catch block within the attempt method. To pass parameters to the function, you simply need to add them as additional parameters to attempt. Our first parameter will be the db.push method bound to the db context. This is the function we want to attempt calling. Our second parameter to attempt will be the /user string with the array index of the user we want to update. The third parameter is our object to update the user. Add a property to this object called lastLogin, which will be the current timestamp. Lodash has a method to generate a timestamp called now, which is an alias for the date.now method. Add another property to the object called token, and to that property we'll assign a call to buff.toString, passing hex as the parameter. This converts the buffer of random bytes generated earlier to a hexadecimal encoded string. This will close out our object to update the user. The fourth and final parameter to attempt is a Boolean flag indicating whether or not we want to overwrite existing data when we call db.push. Since we simply want to add keys to our existing data, this value should be false. Setting this flag to false indicates we want to merge this update with the existing user. When we get our return from attempt, we'll store that in a variable called ret. We need to make sure that ret is not an error object, and to do that we'll use the Lodash isError method from the Lang API. This method is able to detect different types of error objects that could be thrown during execution. Add another if statement to check if ret is not an error object, and if it is not, then we return a JSON response using res.json, passing a success value of true, a message string to say that we've created a user, and a token value that again converts our buffer object to a hexadecimal encoded string. This takes care of the happy path for this route. Now let's handle the errors. Create an else block for the current condition and call the sendError function we created earlier. This handles the failure to update the user in the database. Below the if block for the creation of the buffer, add another else block, and within that block call the sendError function. This handles the failure to generate a random token. Once you have saved the login route, go to your command line and run npm run start to start the Express API server. We're going to test out our login route using curl, but you could also use Postman or another UI application to test the API if you'd like. We need to first get a base64 encoded username and password to send in our basic auth header, so we'll use one of the made-up users in our data store, hchavez3. You can open up your browser's DevTools and use the console to encode the string. Call window.b2a and pass the following string. This is the username and password stored in our JSON DB. Press enter and you'll get back a string which you should copy to your clipboard to add to the curl request. Now go to your command line and enter the curl command. For the authorization header value, use basic followed by the string that you just copied out of the browser console. Once you enter the command, press enter and you should see the successful response with a new token generated for the user. In this video, we covered a lot of ground in getting a login mechanism up and running for our users. We reviewed the middleware that our API uses to validate both an HTTP basic authorization header and a token authorization header that will send with requests from our client. We created a login route to generate a token for a user when they log in and also record the time that they logged in into the application. We learned about several Lodash utilities, including attempt to handle functions with possible error conditions, and isError to check if a variable is an error object. In the next video, we will create the login form that the user will interact with to log into the application, communicating with the API we just created. We'll also update our recipe input form to limit access to logged in users. In the previous video, we looked at creating an endpoint in our API that will log a user in using HTTP basic auth and return a token that the client can submit with subsequent requests to the API. In this video, we are going to take a look at creating a login form to add to our client so an end user can log into the application. We will start by reviewing the login form markup, and then we'll add an event handler to call our API endpoint created in the previous video. We'll take the token we receive on successful login and store it on the client so we can use it in subsequent requests to the API. We will want to display the login form and hide the recipe input form for logged out users, so we'll wrap up our video by adding the necessary code to toggle the display of those forms. Before we get started coding, let's check out the most recent branches to develop. In a command line window, go to your recipes API repo and run git checkout video62. Once the branch is checked out, run npm run start to start the Express API server. In a separate tab or window, go to your recipes client repo and run git checkout video6-2. This will get you the latest code you need to follow along with this video. Then run npm run dev to track the changes made to the JavaScript source files during development. The first thing we'll do is review our login form template. In your editor, open up the template file at app/components/forms/login/template.html. In the file I've created a form that contains two inputs. The first input is for the username field and the second is for the password. The form's method is post and its action is left blank. I've left the action blank because we're going to manage handling the submit event for the form. Now let's open the component controller file at app/components/forms/login/index.js. I've already set the component declaration and added the call to create, along with the render and get template methods. Later on we'll update the render method, but right now we want to add the Lodash methods we'll use in this component. Start by adding attempt from the utility API, which was introduced in the previous video. Next, add isError from the Lang API, which we also just learned. Follow that with the object method get and the string method trim. Once these dependencies are added, let's go to the call to create, and below the constructor property add an events property. Add a submit event type as a property on the events object, and for the value add an array with a single string for the method loginUser. This will handle calling the loginUser method when our form is submitted. Below the events object, let's define our loginUser method. The method should take a single parameter EV for the event object. In the first line of the method, call ev.preventDefault to prevent the default form submission action. On the next line, assign ev.target to a variable called form. We want to get our username and password form field values, and to do that we access form.elements.username.value and form.elements.password.value. Assign the value of each of those properties to variables called username and password. Wrap the form elements values in a call to the Lodash trim method to remove any excess whitespace the user may have typed in. After those assignments, we'll write an if condition to check for the truthy values for the variables username and password. If both variables have values provided from the form, then we're ready to make our call to window.fetch. The URL for window.fetch should be http://127.0.0.1:3000/login, and our second argument to fetch will contain our headers and HTTP method. Create a method property and set its value to post to make a post request. Also create a headers property and set its value to an object literal. We're going to set an accept header value of application/JSON and an authorization header value of the string basic followed by a space and then a call to window.b2a to base64 encode the username and password. Pass a concatenated string of the username followed by a colon and then followed by the password. Remember that window.fetch returns a promise, so chain to that method a call to then so we can handle the resolution of the fetch. In our first callback that receives the response object, we will use an if condition to check a property called response.ok. This value will be true if the response status code is in the range of 200, otherwise it will be false. If response.ok is true, we call response.json to convert the response object into a JSON object. The response.json method also returns a promise, so let's chain a call to then to that method as well. The callback for then should take a single parameter, data, that is the object our API returned. In the handler, create a variable called ret and a variable called token. We'll use the Lodash get method to safely access data.token by passing data as the first parameter and the string token as the second parameter. Below that variable assignment, use an if condition to check if we have a token value. In the if block, we'll use Lodash's attempt method to try accessing the session storage object. Sometimes users disable it in their browser, which will cause a runtime error. Thankfully, with attempt, we can catch that error and return it to our caller. Call attempt, passing session_storage.setItem.bind with the session storage context as the first parameter, the string token as the second parameter, and the token variable as the third parameter. We call bind on the setItem method to prevent a JavaScript illegal invocation error. Assign that call to attempt to the ret variable we created earlier. Next, use the Lodash isError method in an if block to verify that the ret variable is not an error object. If it is not an error object, we know that we are able to successfully set the token in the browser's session storage object. Call location.reload to reload the browser. Now that we've handled all our success conditions on login, let's look at our error conditions. Create an else block for our current if statement, and in the else block, we'll call alert, passing a message to the user that they must enable browser sessions to log in. After closing out the current if-else condition, let's create an else block for the if statement that checks for a token value. If we didn't get a token from the API's success response, that indicates an error in our application, which we may not want to display to the user. We will use console.warn instead to log the error, adding a message that the token was not returned by our API. Finally, let's add an else block for the if condition that checked our response.ok property. If response.ok is false, that either means the server failed in some way or the user provided the wrong credentials. Call alert to pass a message to the user saying we are unable to log you in. Please try again later. Once you close out that else block, our method will be complete. Next, we'll make an adjustment to the render method. We only need to display this form if the browser doesn't have a token for the session, so let's first create a token variable and assign to that variable another call to attempt. This time we'll pass session storage.getItem.bind as the first parameter, and the string token as the second parameter to get the token value from our browser's session storage cache. On the next line, create a variable called isLoggedIn and pass to that variable a guard to see if we have both a non-null token value and a non-error token value, again using the isError method to check our variable. To prevent the form from displaying for logged in users, we'll wrap the assignment to our component's inner HTML in an if condition that checks to see if the isLoggedIn variable is not true. That way the form will only display for logged out users. This is the last change you need to make to the login form component, so once you've completed the changes, save and close the file and we can move on to updating our recipe form component. Now our application's login is complete. The recipe form component isn't useful to a logged out user, so we are going to hide it based on the presence of a token in session storage, the same way we did in the login form. The big difference in this component is that our display logic will exist in the template, which we'll get to in a moment. First, let's open up the recipe form component controller at app/components/forms/recipe/index.js. We need to include a few more Lodash functions, so let's start there. Add requires for the assign method, the attempt method, and the isError method. The method we'll make changes to in this component is render. First, create a variable called token and assign to that variable a call to attempt. We're going to attempt a call to session_storage.getItem again for the token item, so we'll set this call up the same way we did in the login form. On the next line, create a variable called isLoggedIn and assign to that variable a guard to check if the token variable is a non-null value and that the value is not an error, again using isError as we did before. For our call to this.template, wrap the data parameter with a call to assign, passing a default of data or empty object as the first parameter and an object as the second parameter. This object will have a single property called isLoggedIn, which will have a value of the variable isLoggedIn. Below that line, create an if condition to check if isLoggedIn is true and add the keypress event listener inside the if block. There is no need to bind the event handler for our form if it is not rendered. After saving the recipe form JavaScript, open up the recipe form template at app/components/forms/recipe/template.html. Just below the legend element, add a pair of evaluate template delimiters. Inside those delimiters, add an opening if condition that checks if the isLoggedIn variable passed to the template is true. Then, just before the closing field set tag, add two more pairs of evaluate delimiters. In the first pair of delimiters, close the if block and open an else block. In the second pair of delimiters, close the else block. Between the two pairs of delimiters, add a section tag, and within that, add a paragraph tag. Inside those tags, add a message, "You must log in first to be able to add a new recipe." This message will display to logged out users, otherwise the form will display. Once you complete these changes, save the recipe form template. Now we're ready to test out our login form. From the command line in your recipes client repo, run npm run start to initialize the static file server. Then, open up the browser to the following link. Notice how we have a login form below our recipe cards and a message where our recipe form previously existed. Now let's test logging in with an existing username and password combination. We'll use the same combination as we did before with the username hchavez3 and the password capital H, lowercase ah, capital Y, lowercase a, capital WEC. Once you enter those credentials, click the login button. You should see the page reload and the recipe form will now display, allowing you to add new recipes to the application. In this video, we have created a login form for our application that, when submitted, will encode the user's username and password and submit a request to our API. We set the user's token into the browser's session storage and toggle display of both our login form and recipe form based on the presence of a user token. We use Lodash to safely access session storage using attempt and to load an isLoggedIn variable into our template using assign, among other things. In the next video, we will explore additional methods in the Lodash APIs as we work with saving and retrieving the amounts of each recipe ingredient required to make our recipes. In the previous video, we created a login form for our application to authenticate the user. We also added the ability to show or hide both the login form and recipe input form based on the login status of the user. In this video, we are going to build the functionality in our API required to support adding ingredients into our recipe input form. We'll start by reviewing changes in how our recipe ingredient relations will be structured in the data store. We'll then modify our endpoint used to display recipe ingredients to also include the amount of each ingredient required. We will also update our post API route for recipes to save a JSON list of ingredients to our data store, adding new ingredients as needed. We'll finish the section by testing our recipe details API response to verify that the data returned includes the information we'll need on the front end. Before we begin, let's make sure we have the most up-to-date code in our recipes API repo. Go to the command line and from the recipes API repo run git checkout video-6-3. This will get you the data updates you need to begin coding. Let's take a quick look at the data updates in db.json. Specifically, let's take a look at the recipe ingredients mappings. Previously, we had an array of recipe ingredient objects, where each key represented a recipe ID and each value represented an ingredient ID. However, we want to be able to store how much of an ingredient we need for a recipe and what our unit of measurement is for that amount. The way we'll accomplish this in our data store is to map the recipe ID to an object with three properties. The first is an ingredient ID, which was our previous value. The second property is an amount, which could be an integer or floating point number. The third property is a unit of measurement, for instance a cup or a tablespoon. In our API, we can merge these properties into our ingredient objects when we return our recipe, which is what we'll do next. Let's open up our recipe route file at routes/recipes/index.js. The function we're going to update is the getIngredients function, specifically the Lodash filter that we use in that function's return. Our rel ingredients variable, the rel part standing for relation that was previously a list of ingredient IDs, will now be a list of objects. Each object includes an ingredient ID as well as the amount and unit properties described before. We are going to want to get the current object from that list by ID, and then merge those properties in with the ingredients that we are returning. To do that, we'll modify the call to filter. Since we need to find a value in the object within the array, we can use the find method. We'll still pass rel ingredients as the first parameter to find. However, the second parameter should be an object specifying the ingredient ID that we want to search for and the value we want to find, which is ingredient.id. Let's store the return of our call to find in a variable called rel for relation, since it contains the additional properties we need to merge into our ingredient. On the next line, add an if statement to ensure that rel is not undefined using the Lodash isUndefined method, since find will return undefined if the element is not in the collection. If rel has a value, we want to return the result of merging rel into our ingredient. To do this, return a call to assign and pass the ingredient variable as the first parameter. The second parameter will be the rel variable. However, we need to modify it first. Since the ingredient already has an ID property, we don't need the ingredient ID property from the rel object in our response as well. Lodash provides an object API method we can use in this case called omit that will conveniently strip properties out of an object. The omit method takes an object as its first argument and will remove the properties that are specified as additional arguments. So let's wrap our rel variable in a call to omit, and as the second parameter, pass the string ingredient ID to remove that property from our rel object. This will return a filtered array of ingredients for our recipe with amounts and units added. The next modification we need to make is to our post route so that it can accept ingredients from the form and add new ingredients and relations to our recipe. First, add a variable called ingredients with the other var declarations at the top of the function and assign to it the value of post.ingredients. Ingredients will be saved as a JSON list of objects, and each object will include a title, amount, and unit. We need to make sure that we have a unique list of ingredients to post, so we'll use the Lodash uniqueBy method to remove duplicates. Go to the section after the call to db.push after line 169 and set the variable ingredients to a call to uniqueBy, passing the ingredients variable as the first argument and a function that takes ingredient as its parameter as the second argument. Since the ingredient title should be unique per ingredient, we'll return the ingredient.title property as our criteria for making the array unique. We'll also call toLowercase on the title so that we don't have duplicate ingredients that only vary because of their case. If there are duplicates, the first instance will be used while the second is dropped. After the call to uniqueBy, add a variable called dbIngredients that will set to db.getData, passing /ingredients, and then add a variable called lastIngredientID. We'll call the Lodash last method, passing dbIngredients as our array to get the last element of the array. Then we access the ID property on that ingredient to set the last ingredient ID variable. We need to obtain a list of all ingredients that we're trying to save that aren't already in our data store, and to do that we'll use the Lodash remove method like we previously did when saving tags. Create a variable called saveIngredients and assign to it a call to remove. Pass the ingredients variable as the first argument to remove, and a function accepting the ingredient parameter as the second argument. We want to return the ingredients that are not in our DB ingredients list, and to do that we'll return from our function a negation of the return of the find method. Pass to find the DB ingredients list as the first parameter, and an object with a property of title and a value of ingredient.title as the second parameter. The function will return true for any ingredient whose title cannot be found within our DB ingredients list. After the call to remove, let's call db.push to save our new ingredients to the ingredients node of our data store. For the second argument, pass a call to map with the saveIngredients variable as the first argument and a function accepting an ingredient parameter as the second argument. We want to return a new object with an incremented last ingredient ID variable as our new ID property and a title property of recipe.title. Pass false as the third parameter to db.push to merge the new ingredients into the ingredients list. After the call to db.push, call db.save to write the data. Now that we've saved our ingredients list, we need to save our recipe ingredient relations. First, we need to load the ingredient data we just saved. Set the variable db_ingredients to db.getData, passing /ingredients as the argument to load our ingredients list. On the next line, wrap the ingredients variable with the Lodash global and chain to it a call to concat, passing our saveIngredients variable. We call concat here to append the newly saved ingredients to our previously stored ingredients. After that, create a variable called recipe_ingredients and set its value to a call to Lodash map, passing ingredients as the first argument and a function accepting an ingredient parameter as the second argument. In this function, we need to take each ingredient that we are saving, get its ID, and then save that ingredient with its amount and unit to an object that is keyed on the recipe's ID. To start this function, create a variable called rel for relation and make it an empty object. We need to find our recipe in the DB ingredients list, so like before, use find, passing DB ingredients for the first parameter and an object with title as the property and ingredient.title as the value for the second parameter. We'll get the ID property of the result and store it in a variable called ID. We then add a new value to our rel object on the key last ID, which is our recipe ID variable created earlier in the route. The value should be an object with three properties, one called ingredient ID set to our ID variable, another one named amount that is set to our ingredient amount, and finally one named unit that is set to ingredient.unit. Return the rel object from the map function to add a new relation object to the recipe ingredients list for saving. After the call to map, call db.push, passing recipe ingredients as our node to save, the recipe ingredients variable as our list, and false to merge the new relations. After calling db.push, call db.save to save the data. Once you've made these changes, go ahead and save the recipe route file. We're now ready to test out our API response. From the command line in your recipes API repo, run npm run start. This will start up the Express API server. After starting the API server, open your browser to the following URL. This is our API's recipe details endpoint, which is called from the View More link within the application. Notice our ingredients property in the response. It now includes an amount for each ingredient and a unit of measurement for that amount. In this video, we have restructured our data store and our REST API to save and retrieve recipe ingredients that include the amounts required to make the recipe. We modified our recipe details get endpoint and our recipe post endpoint to include recipe amounts and units to measure each amount. We also introduced a new Lodash method from the object API called omit, which is used to remove properties from an object while using a number of methods in the Lodash collection and array APIs to manipulate our data before returning it in our response. In the next video, we will add inputs for ingredients to our recipe form and start saving recipe ingredients and a user ID when we create a new recipe. Once that video is complete, we'll have completed the bulk of our work for the recipes application, and we can move on to talking about application deployment. Hi, and welcome to the last video in section 6, where we will build the necessary inputs to add ingredients to our recipes. The changes made in this video to the client side will complement the changes we made in the previous video to our API. We'll start by reviewing changes to our recipe form template to include an input for ingredients. After that, we will add an event to our JavaScript component to handle adding new ingredients, similar to how we added tags. We'll also handle displaying chips for each ingredient, along with adding the ability to remove a chip from the display. We will also need to add the ingredients input to the post request made to the API, and then we'll wrap up by testing our form with a new recipe. To start, let's check out the necessary code to run our API. In a command line window, go to your Recipes API repo and run git checkout video-6-4 to get the latest API code. Then run npm run start to start up the API server. In a separate command line window or tab, go to your Recipes client repo and run git checkout video-6-4 to get the latest client-side code. After you've checked out the branch, run npm run dev to track the source files for changes necessary to recompile our application code. The first changes we want to review are in our recipe form template. In your editor, open up app/components/forms/recipe/template.html. I have added a new section element just after line 19 where the section for displaying tags closes. The display for ingredients will look just like tags, where each ingredient added to a recipe will be displayed in a chip. The form is slightly more complex though, as we need to support a numeric input for the quantity and a select box for the unit of measurement. When you're done reviewing these changes, close the template file, and we'll move on to working on the JavaScript component. Open the components JavaScript file at app/components/forms/recipe/index.js. The first thing we need to do is add an event for the button we just added in the template. Add a new key to the events hash for click, and assign to that an array with the string for the method addIngredient as the first element and the selector addIngredient as the second element. Below the call to create to assign the recipe forms prototype, add a method called addIngredient. This method should take a single parameter for the event object. On the first line, call ev.preventDefault to cancel any default behaviors. Next, create a variable form and assign to it a call to this.el.querySelector, passing the form tag selector. We need to get our new form elements values and trim them for extra whitespace using Lodash's trim method. So create variables for ingredient, amount, and unit. For ingredient, assign a call to trim, passing form.elements.ingredientTitle.value.toLowercase. For amount, assign a trim to form.elements.ingredientamount.value, and for unit, assign a trim for form.elements.ingredientunit.value. After these assignments, call this.addIngredientLabel, passing the ingredient, amount, and unit variables as parameters. This will close out the addIngredient method. Below the addIngredient method, create a new method called addIngredientLabel, accepting the parameters ingredient, amount, and unit. This is going to work very similar to how the tag labels were created, with the exception of serializing JSON into our hidden input field's value. To start the method, create a variable called Ingredient_Label and assign to it a call to document.createElement to create a span tag. Do the same thing on the next line, assigning it to a variable called removeLabel. After that, create a variable called Ingredient_Labels and assign to it a call to this.el.querySelector, passing the selector recipe ingredients, which is our container for displaying the chips. On the next line, create a variable called recipe ingredients and assign to it a call to this.el.querySelector, passing the selector input with brackets and name equals ingredients as an attribute selector. The last variable will be called simply ingredients initialized to an empty array. On the next line, create an if statement that checks if a trimmed recipe ingredients.value is truthy, which it won't be if that field is empty. This value represents the list of ingredients to save from the hidden form field, so if we have a value for it, we're going to call json.parse, passing the trimmed value and assigning the return to the variable ingredients. After the if condition, we call ingredients.push, adding an object with the following fields: title, which we set to our ingredient variable, amount, which we set to our amount variable, and unit, which is our unit variable. We then assign to recipe ingredients.value a call to json.stringify, passing the ingredients variable to convert it back to a string for the hidden form field. After we set the hidden form field value, we'll need to create the chip. Set the value of Ingredient_Label.TextContent to the ingredient variable, concatenate a colon and a space, then the amount and unit variables separated by a space. On the next line, set the value of Ingredient_Label.ClassName to label space label default for styling. After setting up the ingredient label, set the removeLabel.innerHTML to the close X entity, and set removeLabel.className to label close for styling. After this line, use append child to append the remove label to the ingredient label, and then append ingredient label to the ingredient label's container. On the last line of this function, call removeLabel.addEventListener, passing the click event type as the first parameter. For the second parameter, pass the method this.removeIngredient down to the components this_context, and passing the ingredient label chip and ingredient, amount, and unit variables. The last function we need to create is the removeIngredient function, which will take 4 parameters: the label element, ingredient name, amount, and unit. The first variable we need to create is recipe ingredients, which we'll set to the element of our hidden form input using query selector like we did before. Next, we need to use json.parse again to get the ingredients list from the hidden form field's value and store that in an ingredients variable. Once we've set the ingredients variable, use the Lodash remove method, passing ingredients as the first parameter and an object describing the properties to remove as the second parameter. The object should have a title property set to the ingredient variable, an amount property set to amount, and a unit property set to unit. This will remove the ingredient from the ingredients array. On the following line, set recipe_ingredients.value to json.stringify, passing ingredients as the argument. This will set our hidden form field to a value that does not include the ingredient we just removed. Finally, call this.el.querySelector, passing the recipe ingredient selector to get our labels container, and call removeChild on that element, passing the variable ingredient label, which is the element we want removed. Now that you've made this change, let's take a quick look at how we'll submit these ingredients with the form. In the createRecipe method, we need to set an ingredients variable to the hidden form field. However, we may never have set this value, and if it is undefined, then json.parse will throw an error. To avoid that, we wrap the call to json.parse with a call to the attempt method. For the second parameter, we pass in a trimmed form.elements.ingredients.value. Then, in the body of the post request, we set a property ingredients to either the unique list of unserialized ingredients or an empty array. We use the isError method to check the ingredients variable that was populated by the call to attempt to ensure we don't have a JavaScript error object as our result. Now that we've created our functions to add and remove ingredients, let's test out our form. From the command line in the recipes client repo, run npm run start to begin the static file server. In the browser, open up the following link. We'll need to log into the application first. You can use any credentials you'd like from our db.json file in the recipes API repo. In this case, I'm going to use tgilbert4 with the password capital ED6YGACC lowercase LQTP. Once you log into the application, let's enter a recipe. We'll reuse the pizza recipe and image from section 5, but let's add ingredients this time. Set pizza for the title, add a basic description, and for the tags, set kid-friendly. For ingredients, let's start by adding 2 cups of cheese, then 1 quart of tomato sauce, 4 cups of flour, and 2 tablespoons of olive oil. As you enter each ingredient and amount, click Add Ingredient to add it to the list. When you're done, click Add Recipe, and the recipe card will be added to the page. Click View More in the recipe card, and notice how we have a list of ingredients in the recipe details with the required amounts for each ingredient. In this video, we reviewed the markup and created the JavaScript event handlers necessary to add ingredients into our recipe form for submission to the API. We also tested out entering a new recipe with ingredients and saw the resulting display of ingredients in our recipe details modal in the application. In this section, we have covered both logging a user into the application and adding ingredients into our recipes. We modified the API to check a user's credentials and provide them an access token for their session. We also added a new login form component to the client and modified our existing recipe form component to add ingredients. While doing this, we learned about several new Lodash utilities, including attempt for trapping potential errors, isError for checking if a variable is an error object, and now for getting a current timestamp. We also used omit to remove properties from an object, and find index to get an element's position in a collection. In the next section, we will start looking at ways to prepare our application for deployment. we'll add minification to our build process, and we'll take a look at Lodash CLI and the types of builds it can provide. Hi, and welcome to Section 7 of our video series where we will look at the best ways to prepare our application for deployment. In this section, we'll start by installing the necessary dependencies and updating our build script to produce a minified build of our application for production. We'll then take a look at the features of Lodash CLI, which is a tool available to create highly customizable builds of Lodash. We'll wrap up this section by reviewing our application and then look at the benefits of being able to develop our application using Lodash. Now we move on to the first video of this section that deals with building a minified application for production. We have already installed Browserify to piece together the modules of our front-end application, but we want to create a production build that has a minimal footprint for browsers to download. In this video, you will learn about the tools available to minify your JavaScript code and how to integrate minification into the npm build script. We'll start by looking at the build tools that are available for minifying a JavaScript application. We'll then install Uglify.js, a popular library in the JavaScript build chain to use as our minification tool. After installing Uglify.js, we will add scripts in our package.json file to add minification to our build process. We'll discuss how to integrate these changes into version control and test out the updated build script. Before we begin adding our build tools, let's make sure we're on the latest branch of our codebase. From the command line, go to your recipes client repo and run git checkout video-7-1. This will get you the latest application code that is ready to build. The work in this video will only be in the recipes client repo since we're talking about minification of our code for delivery to the browser. There are a number of minification tools available to JavaScript developers. These include the Google Closure compiler, which can even perform type and assignment checks on your code based on annotations, and the Yahoo UI compressor tool. For our application, we're going to use Uglify.js, a minification tool that has excellent performance and a Node API that integrates well with JavaScript task managers such as Grunt and Gulp. For more information on Uglify.js, visit the homepage at lisperator.net/Uglify.js. Before we start using Uglify.js, we need to install it as a dev dependency using npm. Go back to the command line in your recipes client repo and run the command npm install --save-dev uglify.js. We are going to use the uglify.js command from our npm build script to create a new minified source, but we will also want to have our index.html file load that source. To do that, we'll use another tool called HTML Processor. HTML Processor will use comments in the markup to swap file references when a build is run. This way, we can keep both our app.js and our app.min.js files in version control and simply update which file is loaded during the build. After the installation of Uglify.js is complete, run npm install --save-dev HTML Processor. Once this is complete, we are ready to write our new build scripts. Our build scripts are in the package.json file, so let's open that in our code editor. npm actually allows you to have both pre and post hooks for a script, and we're going to leverage that here to tie all our processes together under the npm run build command. The order that we'll want to run scripts is, first, we'll run Browserify to bundle our modules, second, we'll run Uglify.js to minify the bundle, third, we'll run HTML Processor to update our index.html file to load the minified JavaScript bundle. This order is perfect for a pre-build, build, and post-build script. To do this, start by renaming the build script to pre-build. The contents will remain the same, we just need this to run first. On the next line, create the build script, which we'll call the Uglify.js command. The command is uglify.js assets/js/app.js-c-o assets/js/app.min.js. The -c option instructs Uglify.js to compress the code, renaming variables to shorter versions, usually only a single letter. The -o option defines the output file name, which is provided as the last argument. After adding the build script, on the next line add a post-build script. This script will call HTML Processor and pass index.html as the input file. The only option is -o to specify an output file, which is the same name, index.html. Once you have saved the package.json file, open the index.html file to add a comment for the build script. First, add an HTML comment above the script tag that contains the text build::js assets/js/app.min.js. Then, below the script tag, add another HTML comment with the text /build. This instructs the HTML processor script to replace the source attribute in the script tag between the comments with the attribute value defined in the opening comment. You can optionally provide an environment to the HTML processor command as well as environment-specific comments. That is more advanced than we need though, since we are only running the command for a production environment. Once you've saved the index.html file, go back to your command line and from the root of the recipes client repo run npm run build. You will see the Browserify, Uglify.js, and HTML processor commands execute. When this completes, run npm run start to start up the static file server. Load the following link in your browser, and then open up the browser's development tools to the network tab. Reload the page, and you'll notice a call to app.min.js instead of the app.js file generated by the npm run dev command. It is also less than half the size, an impressive improvement. Something else you might wonder is, how can we take those resources and commit them to version control without altering how development works? A strategy I use for this is to tag a build using git tag. A tag in Git is typically used to mark a release point, and you can commit code to a release branch before creating a tag. Before you run a build, you can create the release branch on a clean repo with your latest code. Then run npm run build, commit the updated assets, and run git tag with your tag name, followed by git push origin -- tags to push the tag to the Git server. Your users can then install the application using those tags and have the production-ready files in place. In this video, we learned about adding minification to our application using Uglify.js. We added a command to our npm build script to minify and compress our code using Uglify.js. We also added a command to update our index.html file to point to the minified code. We finished up by testing out the npm run build command and talking about the best way to add the updated application files to your repository. In the next video, we'll explore other ways to include Lodash in future application development using Lodash CLI, a command line tool used to build customized versions of Lodash for various situations. In the previous video, we learned how to create a minified build of our application using Uglify.js, a popular JavaScript minification and compression tool. We also created a post-build script that would modify our index.html file to include the minified JavaScript and talked about how we could best include these updated assets in our Git repo. In this video, we are going to take a look at Lodash CLI, an npm module that is used to create custom builds of Lodash. We'll start by installing Lodash CLI and then test out the strict and core builds it provides. Lodash CLI can also provide Lodash modules in formats other than CommonJS, and we'll take a look at how to build Lodash with support for alternative module loaders. We will finish up the video by learning how to create Lodash builds with only the specific modules that you'll need. Let's start by installing Lodash CLI. Go to the command line and run npm install -g Lodash CLI. This will install Lodash CLI as a globally available module and link the Lodash executable to your configured path. Once the installation is complete, you can check that it properly installed by running the command Lodash-V. If the installation was a success, you should see the version number output in the console. Now let's take a look at what commands and options are available to the build process by running Lodash-H. You'll see a number of commands available, including standard build types of strict and modularize. We'll create our first build using the strict command, which is the standard Lodash build. When running a build, there are also options you can add, including whether or not to include minified output or source maps for debugging. In our case, we'll run the strict command without any options so you can see both minified and non-minified output. From the command line, run Lodash strict. You'll see the output from the command line as compression is run on the minified output. When the command is complete, you'll see two files in the directory, lodash.custom.js and lodash.custom.min.js. This build should be identical to the one that ships with Lodash by default. Next, let's take a look at the Lodash core command. As I mentioned in section 1, Lodash was originally created as a drop-in replacement for underscore and was intended to provide performant utilities to users of the Backbone framework. The Lodash core build is a stripped-down version of Lodash that is compatible with the latest version of Backbone. Building Lodash core comes in handy when you want to use Lodash as a drop-in replacement for underscore. Let's try out this build. From the command line, run Lodash core-d, which will create a single lodash.js file. Next, run Lodash core, which will generate the lodash.min.js file. Notice the size of the minified build is about 1/5 the size of the strict build, which is very nice if you want to include Lodash as a support library for your Backbone.js application. The way our application was built was using common JS modules, but Lodash CLI supports several module formats. The module formats are built using the Lodash modularize command, and you can pass a specific format using the exports command. Let's try out building Lodash first with AMD module support, which is popular in libraries such as require.js. From the command line, run Lodash modularize exports equals AMD. You'll get a modularized folder, and within that folder you'll see one file for each method, each contained within its own module. If you open one of these files, you'll see that it contains an AMD define statement at the top. Another way we could export Lodash methods are as ES6 modules, which can be used in conjunction with newer libraries such as system.js and Babel. To build Lodash as a group of ES6 modules, run Lodash modularize exports equals ES. When the command is complete, take a look in the modularize folder and open one of the files. You'll see any dependency import statements, a method definition, and an export statement at the bottom of the file. Now that we've taken a look at some of the types of modularized builds that are available, let's look at how we can build Lodash with limited sets of exported modules. With Lodash CLI, you can build either by API groups such as collections and arrays, or even by single methods. Let's try this feature out while also exporting Lodash as a set of npm modules. First, let's remove the modularized folder so we don't have a lot of extra files in the directory. Then, from the command line, run Lodash modularize exports equals npm category equals array. When the command has finished, take a look inside the modularized folder. You'll see directories that represent the various methods within the Lodash array API. Within each directory is an index.js file, the same way that we structured our components for the front end. If you open one of these files, you'll see the require statements for any dependencies, the method definition, and then an assignment to module.exports at the bottom of the file. The final thing we'll do is to try creating a build with specific methods included. Again, let's remove the modularized folder so we don't have excess files after our build, and we can clearly see what was generated. This time, let's include the array, collection, and object APIs, plus attempt and isError. From the command line, run Lodash modularize exports equals ES category equals array, collection, object, include equals attempt, isError. The include command takes a comma-separated list of Lodash methods to include in our build, and the category command takes a comma-separated list of method categories to include. To see what methods are included in the APIs, you can always go to lodash.com/docs to view the full list. When the build is complete, you can look at the contents of the modularized folder to see a file generated for each method specified in the Lodash CLI command. Lodash CLI provides a number of other commands for customizing a Lodash build for your project. To learn more about what each command does, you can run Lodash-H to get the help docs for all of the CLI commands. In this video, we covered Lodash CLI, an npm module that includes commands to customize Lodash builds for your projects. We covered the standard strict build and the Backbone-compatible core build. We also tested several commands for building Lodash modules with various export types using the modularize command. We created modular builds with specific categories of methods and a combination of categories plus other individual methods that we wanted to include. In the next video, we will take a look back on what we've learned about Lodash throughout our video series. We'll review the APIs used and talk about the benefits of using Lodash as the core of a front-end application framework. Hello, and welcome to the last video of Section 7. In the previous video, we learned about Lodash CLI, a tool that can be used to provide customized builds of Lodash for various applications and module systems. We installed Lodash CLI and tested out several types of builds to see how the libraries were created in the file system. In this video, we are going to review the APIs that we learned throughout our video series while reviewing our application. We will talk about the benefits of building our application using Lodash and how we can enhance the client-side application framework we created. We will wrap up the section by introducing some additional resources that you can look at to learn more about Lodash and JavaScript application development. Let's start by loading up our application. From the command line, go to your Recipes API repo and run git checkout master to get the final API. Run npm run start to launch the Express API server. In a separate command line window, go to your Recipes client repo and run git checkout master to get the final application. Run npm run start to launch the Node static file server. Then in your browser, go to the following link. We started our video series by setting up our application repos and installing Lodash. We learned how to install npm modules and how to set up npm scripts that we could use to develop in our application and eventually prepare it for production. In section 2, we learned about Lodash collections, a group of methods that provide iteration and search for both JavaScript arrays and objects. We use some of the more common iterators like for each, map, and filter to build APIs that return lists of recipes and tags for display on the front end. We added search query strings to our recipe listing API, and we built a component to filter recipe cards on the front end by username. We also built a component to display a list of recipe cards and a component to list tags with their totals using grouping methods in the Lodash collection API. In section 3, we started looking at what methods are available for arrays in Lodash while focusing on building the recipe tagging functionality in our application. We learned how to remove duplicates from an array using the unique by method, and we added a recipe input form that included adding a list of tags to a recipe. We built our recipe data list on the back end, and we used Lodash methods to separate tags that needed to be saved to the list from tags that were already saved. We finished this section by building an interface that would display recipe tags as chips and use the Lodash without method to quickly locate and remove tags that were deleted from the interface. In section 4, we learned more about our client-side component framework that is built using Lodash. We learned how to extend objects in Lodash using assign and create new component prototypes using create. We created a reusable event binding system for all components so they could declare what events they would handle. We also allowed components to listen for each other's events, which enabled us to refresh our recipe cards when a user entered a new recipe. To finish this section, we created a reusable input component that was then extended by our recipe filter input and a new search input that we created. We used the Lodash defaults method to set base properties for our input component that could be overridden by inheriting components. In section 5, we continued working on building out the display of our recipe cards by adding additional details using Lodash string methods. We started building more complex templates and learned how to import Lodash methods into a template for looping, conditionals, and more. We also used Lodash to pad and truncate details for display and to capitalize the user's first and last name for the user details section of our templates. Through both sections 4 and 5, we learned about the Lodash lang API that can be used to check variables for different JavaScript types. In section 6, we explored methods in the Lodash utility and date APIs while continuing to add methods from other APIs while adding login to our application. We created middleware for our API to verify authentication for a user on any route that required protection. We also added a login form to our front end and saved our user's token into session storage once logged in. We learned how to trap errors using the Lodash attempt method and how to check for error types using the isError method. Both methods are extremely useful when performing operations that may not be supported based on browser settings, and you can use them to display proper error messages to your users. In section 7, we added minification to the build steps for our application, and we looked at Lodash CLI for creating alternate builds of Lodash. Throughout this course, you have created an API that is able to manage data with very little additional code, and this is in large part thanks to Lodash. One of the most powerful features in Lodash are the iterators available in its collection API. In addition, using Lodash chaining, we are able to collect, filter, and manipulate data using lazy evaluation, ensuring that the fewest number of iterations possible are executed to achieve the desired results. Lodash also has extremely helpful methods for searching lists of objects for matching properties that abstract away boilerplate for looping and checking object properties. This enabled us to add search and login with significantly less code than we would have used without Lodash. On the front end, we are able to create a system of components with the help of Lodash that encapsulate portions of the DOM, adding events and managing user interaction. Using create, we are able to extend a base object while abstracting away managing prototypal inheritance in JavaScript, and we are able to easily add new properties and methods into the prototype as well. Using assign, we are able to add properties to an object in a single call or copy an object based on an existing one. Working to create custom objects with prototypal inheritance in JavaScript has always been a bit confusing, but with Lodash the process is made simple without sacrificing any of the flexibility of the language. We were also able to create an increasingly complex set of templates to separate view logic from the parts of our application that retrieve data and manage user interactions. Adding data to the DOM can at times be an exacting process, but with Lodash we can create variables and execute functions in line in our templates with a single call from our JavaScript code. There are other ways that we can enhance our application as well. The first is our data store. For the sake of simplicity, we are using a library called Node.JS and Express to store a JSON object with all of our data. As our data grows, we would want to migrate to a system that scales better with large data. For relational databases, MySQL or MariaDB are both great choices, and in making the switch to one of those, you would also manage data filtering through both database queries and Lodash. If you would like to learn more about MariaDB, check out mariadb.com. There is also a MariaSQL module for Node.js to use to connect to MariaDB. You can learn more about that module at npmjs.com/package/mariasql. We added search into our application in section 4, however our search API simply checks recipe descriptions for exact matches. Using MariaDB, you could create a full-text search index on recipe descriptions and enhance the recipe list API to perform a full-text search when a query parameter is provided. Another way we can improve upon our existing architecture is authentication. We currently rely on user credentials in our data store and use HTTP basic auth to log into the application. However, many users like the flexibility of being able to use Facebook, Twitter, or other credentials to log into an application, and it would be a benefit to our application to support those. Passport is a very popular library for Node.js that is used to manage authentication through a number of strategies, including HTTP basic auth, Facebook, and Twitter. Take a look at passportjs.org to learn more about how you might integrate Passport into your application. In this section, we have learned more about how we can deploy applications built using Lodash. We added minification to our build process, creating a smaller application footprint for our users. We also were introduced to Lodash CLI and tested out different strategies for building Lodash to support module loaders or applications that require subsets of the available methods. We finished this section by reviewing our application and the APIs we covered in Lodash. We also discussed areas where you could build onto the existing application architecture, making a more resilient and full-featured application for your users. I hope you have enjoyed watching our course, Learning Lodash, as much as I have enjoyed presenting it. In it, we learned the core APIs for creating applications using Lodash as a first-class citizen. We learned these APIs while building an application for creating, tagging, and searching recipes added by various users. This application included its own API, developed using Lodash and Express in Node.js. It also included a group of components that were built to encapsulate functionality on the client side, using Lodash to create and extend components and manage user interactions. We wrapped up our course learning about making our application ready for production and discussing alternate ways to deploy Lodash in our future applications. If you'd like to continue learning more about Lodash, head on over to the docs at lodash.com/docs. There are many methods that go beyond the scope of our course, and the docs contain examples for each method. To learn more about lazy evaluation and how it compares to Lodash, check out the article at filimanjaro.com/blog/2014/introducing lazy evaluation. It is a great article that explains the algorithm at a very high level. If you want your applications to work in older Internet Explorer environments, check out ES5 and ES6 shims, both located at github.com/ESShims. Finally, to look more at the functional programming support Lodash provides, check out Lodash FP, which is available as a set of modules in the core Lodash repo. Thank you again for following along in our video tutorial series, Learning Lodash.